You're live. Okay, let's see. Can you guys see this chat? It
Cool.
says live a couple of seconds. I'm gonna just post to a couple things. Going live with my Tradcoding live stream today. Okay. Post. And post. Okay, we are live. Excellent. That makes me happy. Okay, so I guess I should talk about what it is that I'm doing and why it is. So we're just going to talk about that first, and then we're going to get into actually what it is. So I, for whatever reason, decided I wanted to go write a emulator on ShaderToy. ShaderToy is a website where people can just write little shaders that go run in your browser. But notoriously, people have tried writing processors that live on shaders. And so an example of that on ShaderToy, well, on VRChat is kind of the famous one because of the Linux running inside a shader on a GPU inside a game. I don't know if I could find a video of that. I'm not going to worry about it. But on ShaderToy, there are a handful of people that have kind of attempted this. So some of the machinery is there. So if we look up emulator on ShaderToy, assuming it goes, the people have written things like an apple that can live inside a shader on ShaderToy, assuming it goes. But the thing is, I wanted to do that, but for a more serious processor. And the problem with ShaderToy is you can't load images, so I needed a really, really, really small kernel. And I originally tried little kernel. That was impractical because it was really designed for newer processors than kind of the one I wanted to target. And the second part in between here is on ShaderToy, doing mini RV32IMA is too complicated to run in GLSL. I've tried it a couple times, and the compilers just lose their minds. But what you can do is MIPS. I think. So I started writing a MIPS emulator, same style as I did for mini RV32IMA. And so inside here we have this thing called bittymips, and this right here is enough to run a basic system. Not enough to boot Linux. It doesn't have interrupts or anything like that. But it is enough to build an interesting system. And you can see it's not very much code. It's this whole file here is like 230 lines, and a lot of these instructions actually don't need to exist. So things like seb don't even exist in the base spec. This was when I was trying to port it to little kernel. So I'm probably going to end up removing a lot of these instructions anyway. But the thing was, I tried doing this with little kernel. I tried to make something interesting there so you could boot into it. Oh, here we go. The Apple emulator is up and running. But the thing was, between little kernel being so big and it still not working on my simpler processor, I decided, well, what if I were to just sort of code my own? So I thought about that. Then earlier this week, I got in an argument with somebody on my Discord server, which, by the way, we have a couple people from my Discord joining it. So if you are in my Discord, you can feel free to join the talk too, I guess, and then you're in the thing. Kayla, if you want to just say hi to make sure the levels are okay.
Hello, I just need to unmute the stream as well because I have it muted.
So yeah, if people who are watching the stream right now don't mind letting me know if the levels are okay with that. Anyway, point is, we got in an argument where we were bashing on Zephyr, and it's like, I think Zephyr does have a place, but a lot of people try using it for things I think is kind of inappropriate. I can't share the link to the... Oh, we could share the link to the Discord in the live... No, should we? We could do it for like a 1-day invite, I guess. The problem is we can't have spam, and if you join the Discord, you have to introduce yourself, and we've just had a lot of spam. Yeah, we could do, I think, a 1-day invite. Let me get that set up. How does that work? Invite, edit, expire after. Oh, we could. Yeah, we could do a 12-hour link. And I'll limit it to 25 just in case. Okay. Anyway, we got an argument about Zephyr. And I was like, hey, I think that this is actually a lot heavier than it should be. Because I've done a lot of work professionally with RTOSes in the past. And inevitably, no matter how much resources you have on your chip, you still run into things where you're like, oh, this is so... Insert whatever the resource is that you're constraining. If you have tasks in an RTOS, you have to have the size of all of the stacks be managed ahead of time so that each task can have its own stack. Whereas I think that for most applications, you're actually better off not having a stack. And I'll show you what I mean in my own thing in a little bit. But the whole point of this live stream here is that we're going to be going through this little operating system I've started working on that runs in a virtual MIPS system, and we're going to be working on kind of both the emulator and the operating system. Maybe the emulator is already done. I'm not sure. I mean, it seems like things are at least working enough. I'm probably going to find bugs in it. I already have found a couple. And we're going to be talking about the design of this new operating system. The operating system I'm really trying to keep under, sort of like for a normal sized user interactive session, under about 16 kilobytes. I really don't want to go over that. Sure, like if you throw in a whole bunch of features, it's going to be more than that, but I really want to keep the flash size small, and I'd really like to be able to run on 2 kilobytes of RAM. So like I would really like to be able to target the CH32V003 as a target for this operating system. And yeah, I think that it's going to be a lot of fun to have. It's something that doesn't exist. So like I originally, when I was doing this, I was like, well, surely like there's some alternative to BusyBox that's like BusyBox, but it doesn't require a really heavy OS. And I just couldn't find one. I literally could not find a thing that was like that, but small. And so this is my attempt at that. And by the way, if you are joining the Discord, you have to introduce yourself, like who you are, how you found it, what your interests are. We really do try to watch out for spammers. So, yeah. Anyway, I guess I should start off and... Oh, I guess there is one more thing I want to express is... the reason I'm going towards MIPS is because of Dimitri GR. I don't know how to say his name, his online name in person, but he's somebody who's really pushed for a lot of MIPS-oriented stuff, and he's a very strong critic of RISC-V. And it's kind of funny that, like, a lot of the things that he's described about RISC-V that he thinks is really bad, I think a lot of people agree on, but they're really hard to defend. Like, there are points that are very difficult to articulate a rationale behind. And that's something that's not uncommon with engineering problems, where you have something that, like, the rational and correct way to do things that a bunch of people have thought very hard about can still be wrong. And I think we somehow ended up there with RISC-V. Not that I don't love RISC-V, I do still love RISC-V, but it's got a lot of problems. And one of them really is just that, like, there's just no way you would ever be able to write a RISC-V emulator nearly as tight as this. And that says something about the underlying complexity of the system. So yeah, so I guess we're going to get going. The first one I did want to also call Dimitri out for was he sort of like gave me the shell script for how to get started, which I've kind of turned that into this makefile. And the reason is most operating systems don't have a good embedded MIPS target right now. And so what I have is I've taken his thing and it builds several pieces. And so what it really does is there's a couple things you need, but it's really basic to get going. You just need things like Flex, Bison, GMP, just the prerequisites for building GCC. I don't know why build essentials in there twice. And then what it does is it does everything else. And so if you say just in here, make everything, what this is going to go do is it's going to go download a copy of GCC, it's going to go download a copy of GDB, new lib, bin utils, all of that. And this is the first time I'm running this version of the script, so it might get screwed up, but I'm giving it a shot. and it downloads all of these and it configures them with configurations that are sane and that I know are good for embedded MIPS development. So this isn't like a MIPS-L whatever target. This is like a sort of just raw, no operating system, no kernel, no none of that target. And I'm just going to see where we end up with that. So yeah, so this is all, it's right now on my Codeberg here, bittymips, and this is under toolchain. Oh, shoot. One of the things that I forgot to mention, this is just a general thing everybody should be aware of. I'm going to be leaning towards the expressive style of toolchain, where you say ./export.sh, and what that does is now it says for this terminal use this toolchain and everything. And yes, it did explode. Why did it explode? Let's see, what did I mess up? Oh, yep, that's what it is. This GCC will rely on, yeah, I have to go start building the dependency tree. So this relies on new lib relies on first GCC, first GCC. Oh, it also relies on GDB, and then all of this still relies on let me shrink this back a little bit so I can see what I'm doing. That relies on bin utils. This also relies on bin utils. Oh, actually, this one relies on bin utils as well. Okay, let's try that one. Make everything. Okay, so now it's doing the right thing. I don't know if you guys are familiar with makefiles, but it is really nice with makefiles where you just kind of describe, like, hey, here's the thing I want, here's the things it relies on, and here's the recipe to go build it. And I just really like makefiles for things like this, because if you do then make a change somewhere up the tree, it makes it a lot easier to sort of propagate that forward. So yeah, so right now this looks like it's building bin utils. That's like things like obj copy and things like that for working with ELF files and copying them around. And now, let's see, what is it building now? This is building, oh gosh, it's streaming by so quickly I can't even, this looks like this. Oh, is this like
That looks like newlib. I saw some C++ errors there.
Okay, I'm surprised that newlib would build this. This has got to be GCC. Yeah, this is GCC. Okay, we're building the first GCC base. So GCC is kind of a weird 2-part or 3-part thing depending on the operating system. And so you have to build the first part of GCC in order to build libc, in order to build the final copy of GCC, because GCC uses new lib, but new lib uses GCC. So they get out of that by having a first and a final. And so all of this is now building. I should have timed it. I don't really know how long this process takes, but it's probably about 10 minutes on most people's systems. It is a little bit annoying to build a toolchain. I get it. A lot of people will just want it given to them. Maybe I'll go publish a binary copy of this somewhere. And for Windows, we're definitely going to need to have a binary copy somewhere. I'd like to make it possible for people who use Windows to use this. But it does mean that it's easier for people who, well, I guess you could use Windows Subsystem for Linux on Windows. I don't know. I like Windows native things if I can have them available. At any rate, that's all cooking in the background right now. While that's cooking, let's go take a look at funbox, and let's before we run it, let's take a look at what it really is. So what I have is funbox is split up into 2 parts. I'm probably going to try to keep it as 2, maybe 3 parts. The first one, which is the core of funbox, and this is what describes the operating system. What you have is things that are like called like task-specific functions. So this is like if you want to do file I/O, instead of having a bunch of different functions for reading and writing and all of that, I only have one. And the idea is that you give it a file and you give it an operation, and then you give it data and length. And depending on the file and the operation, it can go do whatever it needs. And it's a virtualized file system. So the idea is that like different files are going to have different callbacks that do different things. And then there's also signals. These are really the 2 core parts of it. And a signal is anything that a process needs to do, whether that's starting, stopping, file activity has happened, waking from a sleep state, whatever it is, it goes through a signal. So an entire process can live entirely as a single function. Files are just, this is the struct that I use for my files. We have to have a port. So port means portability, port like for whatever target it is. And this is sort of like the way that the core operating system goes out and says, hey, I need to open this file. Can you give me the file? Or like, hey, what files are in this folder? And then you have applications. And all an application actually is a function and then a description for how big the data segment of the application is. I might change this because technically all you need is the signal. And this is something to discuss. So I want this live stream to also be discussion. So I get people's feelings on whether this is good or should we change it a little bit. And I'll show you what an application looks like. Actually, let me do that right now. We'll pull up an application. An application, hold on. Here we go. An application, for example, let's do something really simple like echo. Echo right here, if first of all it says, hey, when I'm done, terminate me. So this is basically like a process that will stop as soon as it starts. And if the signal is anything other than start, then don't do anything. Like that's the only thing it knows how to do is just start, do a thing, and die. And then what it'll do is it opens. This doesn't even need to be here. I could just put this right here. Let me just do that right now. And then, yeah, that's literally all it has to do. It has to just print the arg list that you passed in and exits. Yeah, there we go. So this is a tool, a function that's only 3 lines long. And the idea is it doesn't even need state. It's not going to be persisting. It doesn't care. And so that's an example of one application. Another one that's more complicated. Let me see if I can find one that has state. I don't really want shell data. What is cat? There we go. Let's look up cat. So cat is an example where you do have to have state. You have to know like which like if you have cat space a.txt, b.txt, c.txt, you have to know which one that you're currently on. You have to be able to know. Do we even use outno? Oh, we do. Oh, that's for the hex dump. Okay. Don't worry about that. The point is you have to have application state. And so this structure is generated as part of the process when it comes online. And the idea is that anytime that you now have, so we come in here, we can just say cat data D, and we have app data, and that's what this is for our particular application. Think of this as the data segment for a given application, and this is the code segment for that application. And the idea is that this lives throughout the lifetime of the process. Again, maybe we'll change that. Let me actually add that to the to-do of something I would consider changing. Paradigm breaking 3, remove application segment size option, let apps allocate their own memory. And apps can allocate their own memory. Like we have functions for like malloc, free, calloc, realloc, and those take in a process. And so the idea is if a process is killed, then you go clean up the memory behind it, like a normal operating system. So anyway, we have cat, and there's a kind of an interesting thing. You can alias things. So in this case, like xxd, the hex dumper, is aliased to cat. Cat being like cat a file, but you can also hex dump a file. And yeah, let's see, where are we compiling wise? Did it fail? Something failed. What failed? Did I forget to do this? No. Why did this fail?
It configures, but then never builds, I think.
Yeah, but it's because there's an error.
Also, apparently I'm slightly too loud on the stream.
Okay.
According to Venti, I'm louder than you are.
Okay, I can
You might
turn
want
you
to turn
down.
me down just a bit.
Okay, what about here? Is this good?
I will very quickly unmute. Yeah, I think that's better.
Okay, let's fix this build, and I'll go back into the rest of the description of what's going on here. So if I say make... Okay, so no, first GCC is done. If I build new lib, it doesn't work. GCC works. What's going on here? Does that mean that the build target is insane? Is that what the error is? Okay.
There's the error. Configure's complaining that CC's changed between runs.
Oh, well then can I just say rm new lib build?
Oh, also Yuma caught that in chat as well, I think.
Ah, there we go. It's starting. It's cooking. Okay. We'll keep talking while that cooks in the background. I'll leave it just peeping out from under the bottom there so we can keep an eye on it. Anyway, let's close that. So we have the applications. These are all the applications that I have on the system right now. And you can do interesting things. So like sleep here, a process, if it wants to say like do something, be scheduled, go back to sleep or whatever. What I have in, for the example, the sleep command is it wakes up, it looks at the arguments, takes the first argument, and then it says funbox sleep for and how long. In this case, the number of seconds it wants to sleep for. That's right now I'm using microseconds as the main system clock. I don't know. Maybe something will change later with that. I like microseconds as a number. So, and the idea is that as soon as it gets the wake signal, it can go terminate. And then for things like shell, you get, for instance, a funbox child complete event. Okay, that's done. So now if I say make everything. Okay, now it's building the final GCC. Okay, good. For instance, in shell, it needs to know when one of its child processes is complete. And so if a child process is complete, then the shell gets a callback and it says, hey, your signal is my child process is complete. And so in that case, it can reclaim ownership of standard out to itself and then go back to new line, where a user could be interactively typing in, or it would be taking in data from a file. So if you run like a shell file. So let's look at what the host would look like. So this is like an incarnation of this funbox. And so for here, what we do is we have standard out and standard in, and this is calling kb hit and get char, which I have as bitty platform. Those are actually just memory mapped IO right now, and so inside my emulator, sure, I guess we could just look at the whole thing. Why not? Because this is kind of fun how this all goes together. Inside the emulator, for all loads and stores, it specifically looks to see if it's a special address load, and if it is a special address load, it goes into this code. So inside the emulator, I can go into the outside world and be like, hey, what time is it? And then it can look at this current time. Or if it's looking to see like, hey, I need to like get char, like I want to read user input, then we can go into the outside world and read this right here. And yeah, this is a lot like coroutines, except that it is a lot like coroutines. It's so let's not talk about that right yet. Let's go. I want to show the rest of this, and then we can go back into that. But the idea is that that the outside emulator has special memory addresses that if the emulated system talks to, then it will do special things. So in here, what this actually does is it goes and reads from the memory address, and if it says that there is something there waiting, then it can go read it. Otherwise, it just is like, no, I don't have anything. I implemented, for example, dev random, and I did that using the old, not the new, muscle, musl, I don't know how to pronounce that, libc random function, where it just fills in an array of data with that, assuming that, we need to check to make sure we're reading, because we don't want to write if, let me fix that right now. That would be bad if you write to dev random and then whatever you're writing to gets corrupted. Okay. Then what I have is I have a series of files that I'm going to write to various places. And so these mean different things. And so this is inside this portion of the system. I say have dev as a folder or dev memory as a special file. Dev memory is actually kind of funny because it's memory mapped IO. The same as like a string can be memory mapped IO. So like bin init is just literally this string here of pound or exclamation point or hash exclamation point bin sh, welcome to funbox, sleep one, sleep done, and then we go into a getty terminal. Getty is the POSIX way for like you to have a user interactive session, and then it does like urandom in memory, and so what I do is anytime that there's an open, then this code gets executed. So we first say like, hey, is the file in the array of the utilities we know about, and mount that to /bin. Or, hey, is the file inside / and it's inside this array of things here. Or the same thing for directory. So if we want to get the listing of all the files in a folder. Then we have main. And in main, we first set up a funbox, which is, a thing of a funbox is sort of like the operating system. It's not, there's no like memory protection, but it is an operating system that we're running on. And then once we have the operating system existing, we have to do a little bit of a weird thing. This is really unelegant. Maybe we'll fix this at some point in the future. But to get started, you make a proxy process so that it has its own box and a PID. And then you tell funbox to spawn a new process with that as its parent. And then it's a little weird. You hook process one's parent into itself. So process one's parent is itself, and then from process one, the init, bin init, everything else can flow. Shebang is what I've seen. I don't know if pound exclamation point is shebang, or if shebang has to do with shell, like the corn shell or one of the other shells. The code is supposed to be on the other side of the stream. I have always streamed with my picture on the right side of the stream. Anyway, right now, what I'm doing is I have a while one loop, and this is what happens. If I basically say like how much time has passed between the previous iteration and now, and then I call funbox tick with that time, and then I say if the KB is hit, as in like we have a character waiting, then signal the funbox process who's the owner of standard in, like, hey, you have bytes waiting for you, go do something with them. And so this is the operating system right now. Somebody says shebang interprets the kernel, not in any particular shell. Oh, okay. Yeah, okay. And that is what I do. Like if you have a shebang and then something else, the kernel will use that as the interpreter. So let's take some bets here. How big do you? I've shown you the whole operating system, and it does have a user interactive component. How big do you think this is? Like this is MIPS targeted, so there's no compressed instructions. They're all really big, awful instructions. Just some people in chat call out what you think the size of this system is going to be. It is a multi-process system. It can do all these things. 4 kilobytes, 20 kilobytes. Okay, it's somewhere in between. I'll tell you that much. Gosh, Kayla, if you could get this to 4 kilobytes, that would be pretty rad. But I don't know how you do that because
is it not as small as 4 kilobytes?
No, it's bigger than 4 kilobytes.
Okay.
Well, because printf alone is like 1.3 kilobytes. So like, what are you gonna do? Like, yeah.
Could compress some of it and then unpack it into memory
Oh
space.
no, because I need to be able to make my memory 2 kilobytes, and like you have to be able to.
Okay.
Can't have that much overhead. Although I will say, what I'm probably going to do at the end of the day is I'm going to take this kernel. This for the final project is I'll take this kernel, this thing, and I'm going to compress it, and I'm going to write a custom bootloader that lives inside of like a custom boot image, and that's what's going to run on Shader Toy, and then it's going to decompress it to a buffer, because on Shader Toy you have tons of RAM, but you have very limited storage. But I don't want to make that sort of like design decision there. 14 kilobytes is really close. Okay, let's see. Toolchain export.sh. Let's see if we built this correctly. Ooh, oopsies. Well, I did something. So it's 11 kilobytes is the answer, but I'm a little bit concerned. I just changed that to protect it. What did I do wrong? Oh, that's open. That's an open flag. Here it is, funbox read. That's what I actually need. There we go. Oh, it's even smaller. 1168 bytes. So yeah, 11 kilobytes. So now what we can do is we can run the emulator. So I can make clean all. This will be my main like work loop for this. And we're going to call bittymips. Oh, we have to build the emulator. Okay, funbox. Now we'll say clean all bittymips. And then we're going to say -f test.bin. So we're going to just run the raw bin file. And what this is going to do is the emulator is going to take the bin file from disk and then open it up into, I think it's 16 kilobytes of RAM, virtual RAM, and then run it from RAM. So yeah, so you notice that actually took a second to start. Welcome to Funbox and then sleep done. And that's because what it's actually doing is it's interpreting this right here, this little shell file, inside the OS, and that's what the sleep one is. So from here, we have a bunch of commands. We can say like echo hello world, or we can say PS, and we get to see all of the processes that are currently running on the system, or heap. And what heap does is this is for debugging the memory, and what it does is it shows you all of the different processes and where they're living inside of RAM. And so if we want, we could do something like xxd dev memory. And what this is going to do is it's going to show us all of the data in memory. It's basically catting it except as a hex file. And we can go look at it. So for instance, actually what I want to do, I'm going to make a new interactive terminal, but I'm going to give it parameters. It doesn't take any parameters, but I'm going to give it to him anyway. So I'm going to say Getty hello world U. I use U because it's really easy to see in hex. U is 55 hex. So now, if we look at PS, we're actually running inside the shell, inside the Getty, inside the shell, inside the Getty, inside of the shell that's interpreting a init. And so now, that's right. I don't have there's no history yet. I don't know if I'll ever add history. That would probably take more resources than I want to add. I can do xxd, or actually first I have to do heap. And so I can see in the heap, I have to do PS. So process 11. So we care about this Getty shell right here. And so if I look in process number, or in memory 801.2518. So I say xxd dev memory 801.2518. So let's go find that. 2518. Uh-oh. Oh wait, 25. Here we go. 2518. Oh, that's weird. Why? I see the U right here. Did I screw something up? The UUU is now living inside of the bin shell space. 24A8. Yeah, I'm not sure why that is. That's really weird. I would have
When you
expected.
pass in,
Go?
I think when you create with funbox spawn PID, you just pass the argc and argv in. You don't then give ownership of that to the child process. And so I think it's being allocated in the space for bin sh and then being passed to Getty.
Oh, maybe. Okay, let's see how that works. So if we do process spawn, spawn PID, we pass in an argv. Arg list length bytes. Yeah, no, so we malloc it. Who's the owner here? The parent process owns the child processes. Yeah, okay, that's fair. Do I want to do that? What happens if we make a child own its own memory? We can't, because it doesn't exist yet. So yes, a parent process has to own the child process's memory process, so that if it dies, well, does that mean that hold on. Okay, yeah, when you call close process, it cleans it up by freeing it. But it frees it according to its... that's probably wrong. So the problem is that I'm seeing is when you create the memory... This is just really tricky because I don't know how you would... Yeah, I would have to do something where I would like create the process and then reassign the ownership of the memory to that process. No, Linux has a ton more abstractions than this, and the kernel basically handles that one anyway. So, maybe tricky. This is technically wrong because the process block is owned by its own... Oh, you know what? No, I could just tell it that it's the parent. So it'd be funbox processes proc parent or rock. Hold on. Parent PID, that's what it is. Yeah, I think that if I just stored the structure to the parent, that would be better. And that would always be valid. You'd never have a child... Like, one of the rules is that I'm making is that you can't have orphaned processes. Like, that's just not going to be allowed. Let's just see if this works, though. It'll be a little bit bigger because it's got to pull it out. So I would say Getty... Oop. Getty hello world PS... Okay, so that's process 7 is our Getty. Oh. We're still not reowning it. Yeah, okay. So it would be owned by this bin shell and it would just get cleaned up when the process exit. It's fine. It's fine. I'm not going to worry about that right now. Yeah, we'll just live with that. I mean, the point is it seems like it's working. Like it does not just work. Oh! We're already doing it. I should have just looked at the first parameter. the parent process owns it and is clearing up the child. Yeah, okay. Okay. Getty, hello world, you, PS, exit. Yeah, okay, now we're fine, we're fine. Okay. Yeah, that's a bunch of the things you can do here. If you do reboot, it does something really silly, where funbox apps reboot. It literally, get this, for rebooting, you make the process function, the signal, be the beginning of RAM. So when you call reboot, it just jumps to the beginning of RAM. A bunch of fun things like that. There's a bunch of like really hilarious little tidbits here and there. Anyway, this is what I'm working with now. I've talked a whole bunch about, like 40 minutes about this project. This is what I've been spending the last week on, kind of living rent-free in my mind. I've been up until 6 a.m. almost every night because I just couldn't get it out of my mind. And there's a bunch of things I'd love to do with this. I'd love to see more things here. And the idea is that it would allow people to write like embedded systems that are much friendlier as far as the setup is concerned. It's sort of a middle ground between like writing the code for being the code and maybe writing something that could be where you could like SSH in effectively and get to the terminal and start running things and looking around and things like that. So I have made a list of things that I am interested in doing. Oh, we already fixed up the build chain. So that's good. We could do things like make it so that we could do RAMFS files. So I could like in dev have something like SHM where you could write to files. I want to add dictionaries. I've kind of started that. It doesn't work yet. So you can have environment variables or even just have dictionaries because dictionaries are a useful thing that programs like to have. I'd love to be able to make it so that the shell can have get env, set env, and stuff like that. And so you'd be able to say like $, open paren, and have your environment variable. I also want to make the shell yielding so that instead of it just chewing through processor time when it's emulating a script, it can also just say, hey, anybody else who wants to execute, feel free to execute. I'd like to make it so I can track process timing. I don't have a way to do that right now. I'd like to add DD. So like, wouldn't it be fun to say like DD IF equals dev memory, OF equals dash, BS equals 16, count equals 1. Like, wouldn't that be a cool thing to run? And then it would just dump 16 bytes of random data into your main thing there. It'd be really cool if we had a text editor for this. I'm assuming this is going to be kind of heavyweight. This is probably going to add almost a kilobyte to the process overall. But if anybody wanted to do that, that would be kind of fun. I guess I do want to clarify, this is all trad coded right now, 100% me. I really think I'd only accept pull requests from people I trust to not use AI to do the pull requests. And then the other thing is I'm toying with making a fork of this where people could just go nuts with AI. Like have it optimize the snot out of something and just see how hilariously weird it can go. Because I'm sure Claude could do some pretty hilarious things here. But I think I want this to have sort of like the homey feel. Yeah. And some of the other things is, this is something I'm just going to do first maybe, just because I think it's kind of interesting. I want to play with the ABI, because right now if we look at the assembly code for this, what you can see is a whole lot of, for say like some middleman functions, there's a whole lot of work that's done where it's kind of unnecessary stack pushing and pulling. So what I'm thinking I might do is make it so that the functions themselves, if I know a function is not going to clobber any of the temporary registers or any of the saved registers or something like that, I'm just going to, I guess it never clobbers the saved registers, any of the callee registers. I could wrap that inside of a new thing called hard register constraints, and natural versus steroids branches. Oh yeah, like that is an interesting thought. Like, yeah, sure. The AI branch is kind of like for doped competition. Anyway, the ABI stuff I think is really neat because it would mean that there are optimizations you could make, which would be pretty serious optimizations that GCC can't make because of function calls. And I think it'd be a lot of fun to do that for some of them. The one annoying part is it does mean that this would leave the world of like a truly platform agnostic thing and become MIPS specific. And I'm not sure where I want to go with that. Like, do I care more about this operating system being able to run inside any OS, or do I care about this being able to be something that really can be optimized for MIPS only? Not really sure. Yeah. Let's see here. Boop, boop, boop. Be really fun to have a cron D, because that's the kind of thing you need. If I have like a temperature logger or something like that, I want it to go reach out every day over wget or something and send it. And the last one is, I don't know if Bogdan is listening, but SF-HIP integration. Actually, I should at least mention what SF-HIP is. So there's this tool SF-HIP, which is a IP stack, but it is written entirely as a single file header. And so this provides everything from like a web server to UDP, TCP, DHCP, like everything in between, and the whole shebang, all of IP, everything you need, because nobody should be using IPv6. It's all IPv4, and the whole thing is 1605 lines long. And this is kind of, I don't know, it's like a whole, like you could have a funbox that is now networked for just a little bit. Yeah,
it seems pretty heavy. So it's probably not one of the things you'd be able to shove in Shader Toy.
Yeah, I mean, after all, with Shader Toy, it's not like you're going to be talking to the internet anyway. Shader Toy doesn't... Wait, does Shader Toy have connectivity to the internet?
I mean, you could probably do some jank where you use keyboard inputs as your connectivity and then do like IP over serial.
I'm just gonna... I mean, I don't know how that would ever work because cross-site scripting and all, but... I don't even know what I would look for that. I don't think you can. I don't think it's possible. Yeah. Anyway, that's where I am right now. So, what should I do first now that we've started this live stream in earnest? We could do any of these things. I guess just some people call out on chat which ones you think make sense. Let's see, where are we right now? 55 concurrent. That's pretty good. DD? I could do that. Liuma? I don't think TCC is, because TCC... This is a longer story. TCC doesn't want to be a RISC compiler. It is not particularly good at the register allocations. But there are things like SlimCC, which is more reasonable with that sort of stuff, and it's only a little bit bigger than TinyCC. I mean, it is only a little bit bigger. And I think that this totally could be something that would be applicable to this, because you could totally run it on like way more than enough resources on an ESP32 or something. So if you had, I mean, that would be kind of interesting, taking funbox and running it on an ESP32. Like, you know, there are things like that that would totally work out. But yeah. Yielding itself works already. So already processes can say, where is the thing? Funbox sleep 4, and you could just say funbox sleep 4 0, and then funbox will just wake you up next cycle. Next cycle. But this would be adding it to shell. Actually, okay, sure, let's give that a shot. Let's see what happens if we do that. So if we go to funbox apps, and then where do we want to yield? I think in shell I want to yield anytime So process data, file IO. So instead of a do while, what I'm going to do is have so we know that we read a byte. So we're not going to while 1, but we are going to go to sleep. Oh, well, maybe that's all we have to do. Maybe we don't even have to yield. Oh, we do. We will have to yield. 0. And we want to do this inside the if statement. No, it is. Yeah, because we would already terminate. Okay, so we'll be doing it here. So this would yield after every single letter. So why did that not work? Let's go to return. Shoot, that's going to be annoying. Continue. How would we continue here? So this is the backspace key. Can't. Oh, sleep 4. We have to have a process ID. And that's just P. So that didn't work. Why did that not work? Let's just play with this. Let's see, how often is this getting hit? Oh, I need to implement write. I can copy that from here. Okay, so it only got 1 byte in. Ooh, actually, I don't want to do this. Hold on. Or do I? Oh, it really wants to have right. Okay, fine, whatever. Well, I will get it right. Wait, hold on. What happens if I do this? No, okay, fine. We have to do it the other way. Back to the yielding. So inside of funbox apps, cont, we say we printf we want to sleep for 1. So let's see, how do we get to process data? Maybe we're not accepting the right kind of event. Oh, or signal equals funbox wake. Oh, equals. Hey! Hey, check that out. Okay. Perfect. Okay. So what's happening here, every time you see the exclamation point, that is shell yielding. So it can yield to let the processor do whatever else it wants. Yeah, let's do that. I think that's it. Now shell yields.
Greetings.
Hello. We're doing the live stream, so keep it on topic.
Sure. What's the live stream? What's the live stream about?
Oh, check in with the other chat first, and then they'll explain it to you.
All right.
Okay, well that was easy. Let's start crossing some things off the list. Big shell yielding. Okay. Oh, good. There was 2 1s and 2 3s, and now we got rid of both the extras. Okay. Next one. Let's see. Somebody called out DD. Let's go code DD now. So DD is actually an interesting thing. And the reason is it's possible to make DD better and faster if we had environment variables. And the reason I say that is you need to parse DD. You need to be able to say, like, hey, like when we write DD stuff, it's like DD IF equals blah, OF equals blah, BS equals blah. Wouldn't it be cool if there was something where you could just call a function that says, like, DD, or not DD, given this thing, this set of parameters, this set of whatever, tell me what IF is. Tell me what OF is. Like, without having to go parse all of the command line myself, I would rather be able to just say, hey, what is, and whatever that is, I would just like a pointer to it. So I'd like, if it's IF equals blah, I just want blah. I don't want to have to go parse through a character at a time and find IF and all of that. And so maybe it makes sense to start writing the dictionary stuff first. Yeah, let me get into that. So why does my... Ah, that looks better. Oh yeah, nice and chunky font. Okay. Actually, is that better, or was it better without the chunk? What do you guys think?
I mean, I'm very used to gedit, so I don't think I'd know.
What do you mean?
Like, when I used the old font you had for gedit, I've used that for years, so I wouldn't be able to tell if it's better or not. Just purely because I've never tried to play with it.
Oh, you mean Consolus is the default one?
Yes, I used Consolus.
Wait, is there not Consolus on my system? You don't like that. Okay. Uh-oh. Okay, there we go. Anyway. So yeah, I guess that would mean let's start working on the dictionary. So originally I was thinking that a dictionary would just be a size and a bunch of raw data. But what I think I'm going to switch it up for is I think what I want to have is I want it to be formatted like argv and argc, so that it could be effectively like a parameter list. So that way we could work with parameters using functions, or we could work with environment variables using functions, or we could have a totally different thing that if we want to store a dictionary for some reason, we could use that. And what we do for that is we have a argc and a char star star argv. So using these two extra things right here and here for the dictionary, I know it's more space. It's like 8 bytes more space. Oh my gosh. But by having these two extra things, it means that we can then, or could we just reuse argv 0? Could we do that? Could this be a dictionary? I would want it to be all one thing. I think adding things to the dictionary is allowed to be slow. I don't want to have a whole bunch of allocations.
As you've described it, it sounds more like a custom delimiter system, where it just takes an arg list and then it breaks it up by delimiter and then puts it into a list and processes it.
Right. So the thing is, like, would I want to be able to support binary values and binary keys? And I think the answer is I don't. I think it's okay to have text. Where do we stand right? Ooh, boy. Oh, it's because the dictionary code's all wrong now. We're right now at about 11,260 bytes. So 11.2 kilobytes. Mutate the argv arguments themselves and replace with a \u. So I don't want to do =\u. And the other thing is you really don't have to worry about it, because if it's after the equal sign, it's already going to be null terminated at its own end. So you just give it the pointer to the thing after the equal sign. So like getEnv is going to just return to you a pointer of the data that's after the equal sign. So that's fine. But I don't know. Do I want to do it this way? Like, so a couple things we'd have to do with dictionaries: allocate, modify, deallocate. Could we just always assume that? Could we be really evil? No, we would still want this to be dynamic. Or do we? Okay, so I have an idea. We have argc and argv, and argv points to the different strings, and whenever you make a dictionary, the contents of the dictionary are added to the struct itself. So, yeah.
I think a better question to ask, I think that's been slightly lost, is what's the intention behind using this dictionary?
So the two things I want to use it for is environment variables and parameter lists. So if you have something that's like DD where you have equals parameters, which I really like that syntax, and I think I would use that for more things, instead of like flags where you say like -f something, if I just said file equals something, I think I like that better. And then you could reuse the dictionary code in both of those applications. So it would be for environment variables and parameter lists.
Okay, I see. That makes sense.
Yeah, I think that would work. This is going to take a lot of tearing up the existing infrastructure, but that's probably for the best, because we get to make it so that all of that code would then be unified. Yeah. Okay. Let's go for that, and then let's see. The utilities are funbox set dictionary value, or set dictionary set. Yeah, let's go with that. And funbox get dictionary, and so that would be like you would alias getEnv to this. So you'd say like getEnv would basically just Yeah. Yeah. Okay. Oh, there's more discussion. Managing memory directly, I might actually need to scribble a napkin. Yeah, I know. This is a lot of fun, isn't it? You can make them feel more Unixy by prepending the arguments with hyphens and still parse the same way as nvars. You could have a function that says, give me the value for flag X, or does flag Y exist? That's an interesting point, and that would be very, very small, very efficient. Yeah, Liuma, I like that. Yeah. Kayla, what are you... What? Oh, no.
Sorry, I was cooking up a regex in my head about how you do that in a generic way using the same dictionary. You just strip white space, pass word, digit, underscore, dash, and then pass the equals, and then do the same thing again to get the second identifier name.
Okay, so Kayla, how feasible would it be to make regexes part of the core OS? As in,
no, I wasn't saying implement it as a regex parser. I was saying, like, this is like the template for the parser you need to write.
But think about that. What if regexes were how you actually do things in a lot of times?
I mean, I think it's an interesting idea, but I think the entire stream would just be writing a regex parser.
Yeah, or like somebody else would need to do that, like as an aside. But also, I'm not that strong with regexes myself, so I don't know. We'd probably spend a lot of time not getting very far.
Yeah, I think that would be the problem. Regexes are really useful for describing a grammar and not much else.
Okay. So this is a little bit weird. The one thing I'm still thinking about is this is strange because this could be...
I think that was Slick.
What?
I think that was Slick disconnecting. It was. Yeah, ignore me.
Okay. So this means we can only use dictionaries as pointers. Do we want to do that, though? Because it would be nice to be able to use it as a parameter. No, I think... Okay. Use dictionaries as pointers. I think that's right. Pointer to dictionary. Because the dictionaries themselves, this struct will be variable sized. Yeah. Okay, and then let's go write, do we need to do...
How do you want to store the actual elements of the dictionary? Do you want to do them as slices into the void elements, not the void, the
well, they're
string
not
elements
slices.
themselves as
They're...
part of argv?
I think I really want to do argc and argv, so they're not slices. They're just the pointers to the beginning of the strings.
Oh, so you take an argc and argv, and then you create another list from that contains the actual elements of the dictionary key and value.
Yeah.
Okay, that makes sense.
Oh, this is so weird. Yeah. I think.
Yeah, in my mind, it makes more sense that you pass in argc and argv when first creating the dictionary. So you have like a function that takes in those, makes the dictionary, and then processes it.
But I'm saying, like, you could have the entire thing be this. So anytime you want to add something else to it, you would just delete the whole thing and build it again.
Oh, okay. And I imagine if that's fast enough, it wouldn't be a problem. I
think it is.
Okay.
Each program might know an upper bound of the supported arguments. You could theoretically pre-allocate. I could... But it's really the responsibility of the shell to figure out how many parameters you're going to need in the slave application. Am I allowed to say like payload bracket 0? Does that work?
Yes, but it doesn't actually allocate any space in the struct.
That's what I want.
Yeah.
Like when I malloc it, let's just make sure here.
Yeah, I think all that does is create. Yeah, I think it's a GCC extension. It just creates a zero-sized element.
Oh, this isn't going to compile anyway because I need to rewrite half the program or half the operating system now. Okay.
Yeah, because you've changed how dictionaries work.
Yeah. Okay.
Yeah,
well, let's
empty
just
bits
assume
that also works.
Okay, let's just assume that that's right. Let's just make the entire live stream today writing the dictionary. If we get that done, I'll consider it a good day. Okay, let's see here. So where was the first error? Funbox 209. Oh, we need to show line numbers. Oh, it's not supposed to be there. Funbox.c line 119. Proc argc is argc. That no longer exists. So right now that's going to be okay, so these arguments will live inside the current. Okay, I know this looks really weird, but in memory, command line is just an extension of the process block. So like it just keeps going on in memory. I would rather just create a whole new dictionary anytime I modify it. I'm much more focused on keeping it sort of simple, compact, and efficient in that way. And I feel like it's okay. Like, you better not be doing that every frame. Like, that's for, like, you to do when you're setting up your session or something like that. So I think it's okay to regenerate the dictionary every time. Proc end is 0. So we're not going to use any of the environment variables right now. Okay. Let's do calloc so we don't have to do any of this. End of proc where args live. It's no longer that. It's going to be a little bit further out. So those live here now. Oh, actually, it's going to be in exactly the same place. This is. I'm going to add a comment for that. So what this is actually saying here is, oh, this is even weirder. The argv char star star. It's a list of... No, this is very strange. We don't want it to be a char star star here. What do we want here? Yeah, this is even quirkier. Oh, good grief. How do I explain this? Okay, does that make sense? So in memory, the struct becomes argc, arg0 pointer, arg1 pointer, arg2 pointer, arg. Is that reasonable, or is that just insane? I think it's reasonable.
I think that makes sense.
Okay, so we no longer have an argv here. We do have an argv. No, but there's no argv. No, none of that. There is no more argv. Let's just forget that. Okay. Okay, so what this is doing here is this is actually, so create process takes on an argc and an argv and the parent. So instead, it should just take on a parent and a dictionary. Yeah. And then it'll copy the dictionaries to each other. Yes.
Once the process is created, who owns the dictionary? Is it the parent or the child?
Oh, that'll be the child. So the idea is that when you pass this in, the dictionary will be the parent's dictionary, and then the child will get a copy of that dictionary. And then the parent can discard the dictionary.
Okay, that makes sense.
Because that means that the dictionary could live on the stack? No. Why? Maybe I'm making this more complicated than it needs to be. I would like a convenient way for the parent to... Let's just go with it. Let's just try this. I think the thing that makes this really alluring is it makes like this function much cleaner. So we're doing all this work to figure out how many... We need a little bit more helpers. Hold on here. So dictionaries... Did I accidentally delete some? I did. Okay. Okay, we can at least start doing this. Let's start building it from the bottom up. So we'll need a function to get the dictionary size. We'll worry about rewriting these functions later because they need to be totally rewritten. Okay, get dictionary size. So what we're going to do is we're going to say int argc is d argc. Then we're going to say, do we want to store... Well, there's an alternative. We could store an extra value, which is the total binary size. But no, we would still need to store the size. No. Dictionaries will not have blobs in them. Dictionaries will only have valid, like a ASCII and junk like that. Let's do that. Int total length is size of funbox dictionary. For argc I++, total length plus equals 4, or size of char star plus strlen of d argv I, return total length. I think that's right. So what this is going to do is this is going to iterate through the dictionary, and it's going to say it's going to be 4 bytes for the int argc. Then it's going to have to store the pointers to the various things in the dictionary and the length of the various items within the dictionary. Okay, so now let's go back to spawn. So the arg list length bytes. Okay. We don't need that. Let's move that down some. So we're gonna send size of funbox process plus arg length bytes. And it's actually, we don't want the dictionary size. We want the dictionary additional size. And that what that means is we don't want it to include the size of the dictionary to begin with. Okay. And then that's going to make it so that because inside of our thing we already have the funbox dictionary, yeah, because we already have command line here. It's going to be included. Okay. So...
Do you not need space for argc as well?
We already have space for argc because of this. This only includes space for argc, but it does include space for argc.
Yes, of course.
And that's even more elegant because if your dictionary has 0 elements, then it is of size 4 anyway. Okay. Is it missing? Oh, it is. Good catch. Good catch, Thomas. Thank you so much. +1. +1 for null terminators. Okay. Okay. Ooh, funbox print arg list. That's going to be changed to funbox print dictionary. And funbox print dictionary is going to take on a file and a dictionary. And then we're going to say funbox print arg list. And bam. And we're going to say dictionary args int argc. Do we want to do that? I don't know how small it is. Well, let's try that. And then we'll do dictionary argvn. Okay, that was easy. Let's go back to spawn. Okay, so arg list length bytes. So it's the size of a funbox process plus the arg length in bytes. I think that's a lot more elegant. We want to include the to do. Should the envvars struct live after this? I think the answer is yes. Yeah. But we're not going to do that quite yet. We're not doing envvars support. Not yet. Proc command line argc, we no longer do that. Well, I guess here's we're gonna say void funbox copy dictionary. No, that's even weirder. We already have the dictionary. We can just mem copy it in. Oh, no, but argv is going to be broken pointer-wise. So, no, we do need it. P target source assumes target has already been allocated. Okay, so let's go write this. Oh, argc. Stir copy return. No, I'll manually copy. We also want to get the null, so that'll just be... Okay, so... This is getting uglier and uglier. Oh, now we don't even need n anymore. Okay, this is getting silly. I don't know if you guys like watching people write string operations manually. I can't say I don't mind, I don't like it, but I would imagine this is particularly boring to watch. And then we don't need n anymore. Okay, now that's really elegant. Okay, so what we've done here is Omar, I put a Discord share link at the very top of the chat here. You can use that. It should be good for the next 12 hours. Where is that? It's right here. It's like very early on.
Yeah, I mean, my chat has stopped scrolling up, so maybe...
Oh, okay. Then I will repost it.
Yeah.
Oh, Vikoskiv. R5000 is a newer MIPS than this, but they are very similar. So I'm doing this targeting in a MIPS R3900. Specifically, the R3900 does not have a load or memory delay slot. Yeah, it doesn't have a memory delay slot, and there's really no reason to have memory delay slots if you're emulating a system. So it has the branch delay slot, but that's also kind of neat that I'm going to just go to on a total aside here. When you're emulating, actually one of the interesting parts is if you're emulating on hardware that has branch prediction and stuff like that, you're really better off doing the delayed operations. So what'll happen is it'll go try to get the stuff from RAM. It won't use that next, so you don't have a data dependency. So it's actually processing the previous instruction while it's fetching the next instruction from RAM. And so emulating a MIPS is actually really fast. Yeah. Yes, I've done a lot of DMA stuff with the CH32. Man, also long term, I really want to make it so that this runs on the CH32. Anyway, I think this is it. I think this is the whole function. And we don't even need the process. Right? It copies all the strings, it sets the argc, it sets the argvs, and it's done.
I mean, I imagine you could have a process there if you want to immediately insert it into the process, but that doesn't seem like the main utility of this function.
No, I mean, I just include the process because if you ever need to allocate memory, then you have to have the process ID to allocate.
Yeah, but you're not...
Yeah, there's no allocation
in the process. Yeah.
Yeah, okay. So then let's go back to spawn.
I will say, the reason I switched over to only using slices in C is just because I hate doing string manipulation in C.
I know, I get it, but...
It's an annoying and difficult change to make because nothing in C does slices first.
You know, okay,
you
so that would be like an
agenda
agenda thing. Like if you had an agenda for an operating system where it would all use slices, you totally could have a world where that's just how it works. But I kind of want to just leave it how it, like I want to make this more like old school POSIX than have something that's necessarily like new and good. See, that would be fun though. That would be an interesting trade-off. I mean, okay, so if we keep the operating system simple, Kayla, if you wanted, you could try to like make the entire operating system use slices instead and see where you end up. Like maybe
I mean, I think it would increase the memory usage like by probably like 5%, I think.
Maybe.
Just for all of the bookkeeping on strings.
You're right though, but well, yeah, because you only need a single null to do termination. Yeah, let's not do that right now. I don't want to mess with that.
Yeah. There's a reason I was like, oh yeah, don't go for strings, and it's because it'll increase the amount of memory you use.
Okay. We're not going to mess with nvars right now. And we're going to copy dictionaries. So proc, what was it called? Args? I don't remember anymore. Oh, proc command line. And it's the args. Okay. To do copy parents. Oh, hold on. Proc parent. Where do I get parent? Parent pointer is somewhere here, right?
You just have a pointer called parent.
Oh, literally parent. I could do parent. Oh, you know what? Let's do that. Because we're already going to do this. Arg list and arg list length bytes and env list length bytes, and that'll be parent env. Is it called env? Is that what we called it? Yeah, parent env. Yeah, okay, so now the environment variable just lives at the end of the thing. Okay. And then now we can say proc end is equal to proc +1 plus arg list length bytes. Void star. Oh, no, this first part needs to be a void star. Okay. And then we can copy... Oh, I got this backwards, didn't I? Is it destination first or source first? It should always be destination first. Yeah, target source. Okay. Target source. Target is actually going to be proc env. Source is the parent's env. Okay. We no longer need to do all this wacky memcopy junk anymore. We will need to look at argv in some special way. Wait, I just got some ping. I don't know where the ping came from. Oh, somebody, okay. argv. Find argv. So we have to load from the first parameter, and so that's actually going to be args argv0. Oh, okay, that was easy. Let's store that aside. Const char star argv0. Okay. Copy the dictionary. Go through the path. Possibly load the data segment. And this goes back into what I talked about, like maybe we don't have data segments and all processes just have to allocate their own memory. Why do I even have the data segment? Well, we'll tear that one up later. That's just wasteful. Okay. argv0. Okay, so now the process function should run. We'll still have problems elsewhere. What did I mess up? Oh, I forgot to copy the function signature. This is cleaner. Parent args. Yeah, this is so much cleaner. You would spawn something where you give it the args and you give it the standard in, standard out, and standard error. That seems brain dead simple. Let's go with that. I love how with this sort of thing, like, people a long time ago kind of figured out the simple way to go, and it's just been so, like, oops. Yeah, int. Okay, so this is all fine. Okay. Now, funbox apps line 48. Yes, that's going to be all screwed up now. Does that work? Oh, it's... You know what? Okay, should I call this args or command line? Because I'm intermixing them right now.
I think settle on command line, because that's meant to be the main way of interfacing with them.
Yeah. Okay, yeah, I'll do that. Ooh. So we will... Oh, come on. Where else do we use argv? There we go. You know, the nice part is even though this looks uglier, it's still going to be just as fast because it's just a different offset in the file where the argv is. Oh, actually, this is really convenient. This is gonna need to be rewritten. Ugh. Ugh. Ugh.
That is a nasty printf.
Yeah. Which function is this? This is free. If you type in free. Oh, because I have a thing called free-v where it shows the total memory usage per thing. Oof. Oof. Okay, Getty. Okay, Getty's a little weird now. Oh, Getty will always launch bin sh with only one parameter being the execute. Do we want to have a helper for creating these dictionaries?
I think so. So you can create a dictionary and then say, hey, here's my argc, here's my argv, just process it.
Yeah. Yeah. Actually, let's be really, probably too clever. So one of the things, I don't know if you saw yet, is GCC 16 no longer produces insane code when you use variadic functions. So we could do that. We could do something like funbox. Oh, better yet. Funbox dictionary star create funbox create dictionary. And we could pass it in funbox process p and int argc dot dot dot. What do you think about that function? That's going to be... I can't wait to write this one. This one's going to be wild.
That might be a bit difficult if you've already got argv.
Shoot.
Like,
You know-
you might have one that's like create dictionary variadic that lets you do this, and then create dictionary just takes argv.
There's a problem. I think I need to know how big it is before this. Is there any way with variadic to say like, hey, I want to go through all the parameters. Oh, and I want to go through all the parameters again. Is that possible?
What do you mean? So iterate through all the variadic args and then restart it?
Yeah.
I think you would use VA copy for that. You would have a normal VA list. You do VA copy to get a duplicate of that list. And then you iterate through the first one, VA start to VA end. And then you can iterate through the second one, VA start to VA end.
Okay, let's give that a shot. This would feel like this tickles the tism just right to do it this way for me, so...
Yeah, the only reason I say don't just do VA start again is because the standard says if you do VA end, it can clean up the list to make it no longer usable.
Okay, then we'll do that. Well, we know that they're all going to be pointers. How inefficient do you think it would be to do 2 VA lists? Like, would I be better off just allocating a bunch of... Like, when I first go through... Like, would I be better off saying, like, char star argvs max something? You know, like... 100? I don't know. No. That's Kayla. Is the second voice. I'm doing this with somebody else. Yeah. I don't know which one of these would be worse. Wait a minute. We know how big it is. Oh, yeah. Oh, yeah. Look at this. Look at this. Look at this. Look at this. Int I. Okay, no, we're cooking. We're cooking. We're cooking with gas. Got it. Okay. VA start args. Argc. 4 I equals 0. Okay. Yeah, we're gonna do this. I want argc I plus plus. Argvs. I is equal to oh, how do you write this? I've forgotten how to write this part. Arg. Okay, that's actually not that bad. Okay, so we pull off all the args. Oh, better yet, int string length is 0. Oh. Oh, we still have to go through the list again, but we could do that and, although annoyingly, we need to do exactly this there as well. Maybe this should be a function. Okay, we'll just do it here. We'll do it this way. Int argv lens argc. Int lens equal to I.
You'll find with these being variable length arrays, right?
Well,
Just
they're on the
stack
stack, right?
Yeah, yeah. Okay, yeah, but you're not resizing them, so it shouldn't be a problem.
Correct. Because I know the size. That's what was the clever part, was that, like, I know the size when I start. Okay, so funbox ret is funbox malloc p, and then the size is going to be size of funbox dictionary plus size of char star times argc plus string length. Oh, could I just... I don't need this. Oh, I do if I don't want to go through it again. The whole application is 11 kilobytes. The RAM is... I'm trying to target a 2 kilobyte RAM limit, so that has to hold the stack and the heap and the processes, so... Not huge. I'm just trying to avoid stepping over the list twice. I think I can do that, though. No, I can't. I can know the size. We'll just go through it twice. There's no... We already have to step through it anyway. Okay. Yeah. Okay, so we alloc it. Ret argc equals argc. Argv I is equal to stir start. Do that right here. Stir at instead of start, and then what we're gonna do is do stir at plus plus is equal to read from plus plus char c is that while c. Does this do everything?
Why is there a +1 after ret?
What?
There, you do chance.ret +1.
Well, really, what I should say is the address of argv ret argv of 0. That's a much cleaner way, I think, to say it.
Yeah, because I think that's what you were going for. It's just I couldn't see it in my head, I don't think.
Yeah. Yeah, that's a much cleaner way to... Writing code with somebody else is so much better, because, that's a much better way to write it, and I just didn't think of it. Okay. Oh, this needs to be defined outside. Is that legal? I don't know if that's even legal. Oh, yeah, no, that's not legal. Okay. Okay. Wait, can I... Is this legal? I've never written a one-line... If that's legal, I'm gonna laugh. That's... I already did laugh. And it is legal. Okay.
I think it is.
That is, That's something... Wait a minute. Can you do this? No. Okay, okay. I was going to... okay. Yeah, okay, let's go for it. Oh, also, always FF Rohan. I'm not even using something to automate my my indentation. So this is all trad coded. Okay, so this I think should do the right thing. Wait, where were we? Funbox apps line 54.
Wait, have you copied in the pointers to argv yet? Into there? Because you've copied in the strings.
I think I did, unless I misremembered what I just did.
Unless I'm misreading it, because it's...
Right here.
Yeah, you're copying in argv I equals star at. Yep.
Okay. Man, this function makes me very happy. So one of the things I should mention to everybody else on the stream, when I'm writing these functions, I'm thinking about what the compiler should produce the code. So I think about, like, okay, how big is the stack going to have to be? What is it going to do to deal with that? How is the struct going to be structured? If I look at this right here, I think about this, and it's like, well, would it be faster to have an index and then reference the index and increment the index? But then it would have to add the two, because on MIPS, there's no instruction to say, read from the effective address made by this pointer plus this value. So, like, this is probably the faster way to go. Yeah. So, but yeah, that's what I'm thinking about when I'm writing this, is like, how do I write it so that it will be tight in normal, like all together. And like things like this will become a shift over by 2 from argc. I should probably define that. argv_len. I think that makes it a little bit clearer what's going on there. Okay. Yeah, I'm proud of this function. I would put this on a resume. Okay. Reset make. Funbox apps line 85. Why is that not right? Oh, the function name changed. Oh, that means okay, so just one thing. That means that echo is now going to be like 4 bytes smaller. Okay, what's next? Funbox spawn PID. Ooh, this is now a different function. Parent args. Okay. Parent is P. Oh yeah, that's why we did that. Args. Or this is now actually command line. And we should probably change the name of that here to be command line. Okay. And what was that function that we did? It was create dictionary. So we're going to funbox create dictionary 1. Sorry, P, because that's who we are. 1. Oh, shoot. I don't want to make a dictionary here, because that's going to have to allocate a dictionary.
It needs to allocate one, but it's not a huge one, is it?
No, but I don't want to do a heap allocation. I really want to do it on the stack. Is it valid to say like char is that, and then what I would do is I would say funbox dictionary star fbd is equal to oh, you know, it's not a hard rule that the data lives right afterwards. Can I do that? I think I can do that. Is that valid? Allocation, load, set. I think that would be
no,
Why
because
not?
you haven't copied in bin.sh into the.
I don't
RV,
need to.
don't think.
I don't need to. I don't think I do.
Because you've already set it. You've already set it up. Yep.
Yes.
With the command line on stack. Yep.
Hold on. Ooh. Yes. So everywhere, we should note that. Just because that's going to be a foot gun for anybody. Note, it is optional that the arg data exists immediately shortly thereafter. The arg data may exist anywhere. Okay. Yes. If we guarantee that, then that makes a lot of it allows us to be much more free here to do wacky stuff like this. Yes. Hello, everyone. Okay. Let's see. Does that all compile? Line 47. Wait, what did we break now? Funbox.c. Line 47. Oh. Yeah, okay. Oopsies. Next one, line 131. FBD, oh, arrow. Line 150. Oh, p.command_line.argc. Okay, p.command_line.argv. Funbox print arg list. Oh, that's right, we changed the name.
That's using the old layout as well.
Yeah, so we have to change this, and this will have to be command line. Oh, that makes this tighter too. Oh, it makes the code look cleaner. How much bigger do you think this is going to be now with all these changes? Because there's no way it's going to be smaller. It's probably going to be, I don't know, a little bigger.
I'm going to wager about 100 bytes bigger, but it'll have more memory usage.
Yes, that's true. Okay. But I really think this is worth it because it means that as we do more features, the cost of those features is going to be much smaller. Okay, line 204. Args. 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 Oh, what did I mess up here?
I think 212.
Oh, I keep... Dang it. It's... args... command line. I keep... Oh, this has to change. Oh boy. Okay. Well, I guess we make a new dictionary here. Let's see if we can do it in place. Is it possible to do in place again? Yes, it's possible to do in place. Let's wrap this cursed stuff inside of something a little bit less cursed. Or We already have to have argv's and argc effectively. Why not just... Wait, is it that easy? I think it is that easy. Okay, well that was anticlimactic there. I don't know, did you see what I did, Kayla? Like that, I think that's valid.
I mean, from what I saw, sorry, I was tabbed out looking at a code review someone sent me.
So what I'm doing is I'm making a new char array that's the size of the dictionary plus the size of the args, like the number of args times a char star, and then I make a pointer to that value, and now I just write into argv here, and I write out arg's number of argv's.
Yep, I think that's correct.
And then even prettier, we don't even need this last args plus plus. Oh, there's got to be some... Well, I'll bet you there's a bug here for, like, if you have a space at the end or something. Yeah. We need to do this. Oh no, there's already going to be an null terminator there. This might actually be fine. Okay.
I mean, if it's broken, it should be obviously broken, right?
Yeah, that's a good point. Or at least, like, I'll be able to test it real quick.
Speaking of, something that might be useful is getting a GDB multi-arch client into the emulator.
Oh, that would be interesting. I'm not good at that kind of debugging, or like that kind of stuff, but I don't know. I would definitely accept the PR for that from anybody in chat if they, well, yeah, I don't know. I guess I don't want to accept, well, that's frustrating that, like, we live in a low-trust society now because of that. The AI stuff.
Yeah.
Okay, command line argv 0. Oh, we just want that. Yeah. No, that's not right. What is this? Argv's. Okay, I think that's right. Friday. Nope. Okay. So now we're on to the outer box. Okay, this is gonna be weird. Well, I guess we copy what we do in here for when we make the dictionaries. It looks ugly, but it seems to work. Oh, we changed the order of Kayla. The memory usage.
That was a horrifying noise.
The memory usage is so similar. It's smaller. Okay, there's no way this boots though. There's absolutely no way.
That doesn't make sense.
I mean, we refactored out some of the logic.
I guess so. We did take out a couple of functions worth of stuff
And
just
it
reworked it.
Immediately eats dirt. Okay.
Immediately traps. Yep.
Yeah, okay, let's take a look and see where the crash is. Hi, MakerVen. Wait, are you Uni? The icon. I'm looking at MakerVin's icon. So it means it was right here is where the crash happened. So it's when we're getting the initial additional dictionary size. Okay, let's go throw in some printfs there. Well, that's curious. That eats dirt very quickly. Five.
Yeah, that's dying incredibly early.
I have no idea how it's capable of printing the star, but I think it's null. I think that that's what's going on here. What is even going on here? Uh-oh, now I'm worried there's like a emulator bug.
Could this just be memory corruption?
I guess. Whatever, I can print out a number here. Yeah, that's what's going on. So the first one is, well, okay, I'll bet you what's going on is I think there's, based on this, I don't have any extra knowledge behind the scenes, but based on this, I think that it's probably an opcode being misinterpreted somewhere deep within the bowels of the printf that is like close to doing the right thing, but not quite. Anyway,
can you print the emulator state on trap, like what the instruction that caused the trap actually was? Because if we see ASCII characters there in hex, then we know there's been memory corruption.
No. Well, first of all, we're not corrupting memory here. We have a null dereference, and that's what's causing it to explode.
I can't read your trap syntax. That'll be why.
Oh, it's this. This is the instruction that it was executing when it crashed. So the actual problem is 2 instructions back from this. Because it loads one instruction, and then it executes, and then by the time it... Yeah. So I just look in test.lst at 171C, and then I can look right here. This is where the actual crash is happening. And it's happening right here because it's reading dargc. Which it can't read from memory address 0. That's a null pointer dereference, and that's why that's happening. And all of this is happening because our environment variable is null. So if we pass null an additional size, I'm guessing we should just return 0. Okay, 181C. Let's see what that is. Welp. That's weird. Where is this? In shell signal. Okay. It's this. Command line argc equals args is exploding. Why would that explode? What? Oh, I mistyped it. It's 18C. Okay. Here. We are in funbox copy dictionary. Okay. I looked in the wrong place. This code is probably fine. Oh yeah, what if source is null? Ooh.
If source is null, then something's wrong.
No, because if your nvars, I think I should allow nvars to be I think I should allow my nvars to be null.
But if the source is null and you want to copy from it, should it just fill up the target with... should source return nothing? Like, do nothing to the target? Or should it make a reasonable nothing target?
That's a good question. What would we expect to happen there? Hi, Uni. I just noticed that was you. Friday, did you want to say hi? He keeps coming over here, but not quite. Friday's... Oh, come on. Here, you gotta get a little closer. Let's see. So if we copy, if our source is null, okay, so target is 0, we return. If source is 0, then we set target argc equals 0, return. Okay, where are we crashing out? 1A4. Hi, Waffles. As a reminder to anybody in chat right now, this is going on also on my Discord server. So if you hop into Talk 2, I guess, it'll be on... if you hop into my Discord server, it'll be on Talk 2. And I have a link above. We could repaste it later. Oh, Friday keeps
Come say hello.
Yeah, Friday keeps come on. Keeps like meandering close to the camera but not being on camera. So let's see here. Why is this crashing? We're reading from source argv of I. Okay, so then maybe the answer is we just print f this value. Let's see what's actually going on here. I'm curious. Is it on like the 0th element? 0. Okay. E24. Why is this all of a sudden misbehaving? Okay, so it's pointing to somewhere on the stack. Oh, okay, let's see where that's pointing. No, that's pointing to actual memory. So what is the problem? OOE1C. What? Okay, let's take a look. Why is this exploding? Okay, so this is... What is this even doing? Oh, maybe it is actually... Okay. Well, that should be valid. Why is that not valid? So it says it's reading from 28. Okay, something is weird here. What is going on with this? Why is... I don't know why. Whatever, who cares? Okay, so it's inside here that the problem is happening. Okay, I don't know. This is starting to get really annoying. I really want the Oh. I think you're right. That was a good catch.
Yes, because it's not what's referenced there.
Yes. Oh my gosh, thank you so much, Thomas. We should have like a disclaimer that like if you're going to call out things in chat, they have to be can't be. Oh, it's still exploding. Let's see, do we at least get to the end? We do. Okay. Let's see if it's in the other version. Oh, we're crashing somewhere else entirely now. Okay, let's clean that up. Okay, 1420. Oh, it's 01420. Okay. We are exploding here. That's concerning. That makes me think that we've somehow destroyed the stack. I don't have any idea how this... Go?
That's my concern. We have memory corruption.
Oh, good grief. I am not adding GDB support on a live stream.
No. That's not what I'm saying, because that's a multi-hour job. And then testing.
Yeah, it is... No, it really is this instruction. I am really worried we have done something wrong here. Come on, this is annoying. There's got to be... I'm not going to debug it on stream, but I feel like it's got to be some bug somewhere in the printf function. Not the printf function, the emulator executing the printf function. So 2320. It's too much work, I feel like, to rip up all the stuff to get back to testing just that function. I really want to just try to plow through. I don't know why I need multiple new lines just to get this thing to emit. Sure, why not more new lines? Okay, what if we put new lines on both sides? Oh my gosh, this is annoying. Whatever. I can still read it. Okay, so it is something about this that is exploding. I think it's if those two are null. Okay, we have to fix this function. We can't go on with printf not working. Okay. How would I debug this? Okay, I'm going to just set okay. I have the ability with my emulator to print out some of the interesting values as it's going. So, wait, oh, I have to... Okay, let's go to town here.
Oh, that's weird at the bottom there.
Oh, no, this is it printing out the number.
No, I mean the final instruction before the trap. I mean...
Oh, that is an interesting instruction. 1408. Okay, let's just look at that anyway. I don't even know how that's possible. Break. Break. Huh. That's weird. I guess maybe the compiler knows that something's gonna go real wrong.
Hold on, are you compiling on with Optimizer on?
Yeah, OS.
Oh, then that's poison.
Oh, well, okay then. That's fine. Whatever, I'm going to try to debug printf now. So we are going into here. Okay, so... Oh, this is inside the write. Okay, so we write out... nop. Then we're going to... Oh, interesting. Okay, hold on. Let's see what the value is. Okay, so F0. So what character are we printing? We are printing... Oh, we're printing a string. Okay. A1 is the pointer to the string. A1 is 801 3E60. And length of 0. Oh, I see. Oh, this is it finishing printing the string. Okay. So the idea is that the S2, it starts with like the normal length. Like it goes like 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. So now what we do is we see branch if equal to 0, and then we're going to jump to 11C. Yeah, so we go to 11C, then we go to 120, which is jump return. Then we go back into 10518. Okay. So we still have more printf stuff to do. And so that is... Okay, so now we're exiting the put s uart function. As to why that needs to be a whole nother function call, maybe we should clean that up at some point. I'll worry about that later. So now we're going to go pop back at 520, 524. Okay, so now here, 00860. That's here. Okay, so now we're in... Okay, so we're in printf. We're going to go to 60006A4. Okay, 6A4. And I know we still have data to go. I know that we still have data that we need to be processing. That's concerning. That's very concerning. That can't be right. Uh-oh. This can't be right. This can't be right. So what I'm looking at is right here, it's saying while char is equal to star format plus plus. So what this is doing is it's now going to, so S0 is the effectively like the format pointer. V0 is going to be char. So it's pulling V0 out of this. But according to this, V0 is just... B800, something's wrong. S0, okay, let's look it up. MIPS registers. That's right. Register 16, register 17, register 18. What's going on? That's not possible. That would be B000. That should totally segfault. Let's... Six A4. Uh-oh. Okay, well, this is bad.
Oh, whoa. That doesn't look like an emulator bug.
No. No, it doesn't. Well, it does. It should crash. Why does this not crash? This should just explode. Oh, interesting. That is a valid pointer to read from inside of the system space. Okay, what is going on here? Okay. We update T1 with that address. Yes. Okay, so that's really interesting. So it's saying it's at the beginning of the special register space. And then what we do is we like operate on the offsets from that to send chars back through the emulator. But that means somehow we're updating S0. When does S0 get set with this value? Here. What is this instruction? In underscore right. What? Hold on. This is just...
Is it? Oh, it might be doing immediate generation. Weirdly.
Oh, I changed this function. I meant to do this. Oh, yeah. 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 Okay, so I literally, inside of my write function, I was editing the call saved registers and blowing them up. Oh my gosh. I did
Okay,
that.
right. That makes sense.
I did that this morning. I don't know why I did that. I don't remember what my rationale was. I wanted to see if it was possible to do the ABI stuff, to say like, oh, I promise I won't touch this value. But clearly I went and...
Yeah, how did it only break now and blow up now?
That's a really good question. But, I don't know.
Yeah, because if it should have blown up, it should have blown up way sooner than doing this refactor should have exposed it.
I mean, it was reading and writing to the first, like, kilobyte of that space has nothing in it. It's just all you read as zeros. So maybe it. Who knows? Who knows? Okay. Oh, yeah. Let's recompile. Okay, we can actually print out numbers again. Okay. Sin is this number, proc is that number, env is that number. Okay. We no longer need to be goofy people, and we can just do normal stuff. Okay. Do we get here? No, we are actually exploding. Okay, 1488.
Have you fixed the funbox copy dictionary when one of the arguments is null?
Did I? I don't know. Let me go look. What did I... Wait, what is this even... even see what it is. Okay, so the first one is valid. Does that even make sense? Yeah, I guess it makes sense that it would be a valid pointer. Oh. What happens if that... You know what we have to do is have... We have to have the nvar for the ending allocated. Okay, so I'm going to actually try to make this a little bit clearer. Process plus dictionary, actually process includes dictionary base plus command line data plus end data.
You don't add, you just have arg list length bytes and then no operator.
Okay, so now it is a... So env is going to be valid here. Which one is echoing? I don't know how echoing would be possible. Oh.
That might be me echoing.
Yes. Yeah. That would be. I don't know a good way around that unless I put on headphones.
It's like Kayla sounds like they're in a large room.
Oh, you know what I could do? I could leave this up so it still has Kayla primarily, but I could turn down how I hear it. So say something again.
Hello.
Okay, yeah. And you probably aren't echoing anymore, right?
It's fine. Apparently it's fine. It's not terrible.
Yeah, you guys can't hear Kayla echo anymore, right?
Yeah, I think it was better now.
Okay.
Okay, so if target is 0, we can't do anything. If source is 0, we set the target argc to 0 and we return. Starting, continuing, okay. %08x, %08x, target source. Target is populated, source is not. Target is populated, source is not. Target argc equals 0. Return mid, return. Why would this crash? Target 8126 246A. Where is that? Okay, so that's in like the heap somewhere. Do I have a map file? Oh, it's not. Yeah, it's inside the inner heap. You know, maybe it makes sense. I think what I'm going to do in 20 minutes is I'm going to take a break from writing the code, and I'm just going to go into the design of this kernel and how everything fits together and what this is actually doing. So yeah, if you guys hang out for another 20 minutes, let's say 5:01 local time, I will go do that. Anyway, because like I'm getting a little bit tired of, or like exhausted of writing this right now.
I mean, I'm not surprised. Big refactor followed by annoying bugs.
Yes. Well, at least all the annoying bugs so far are fixed. Now we're back at the normal bugs, I think. Though I'm really confused how this is failing. We should totally be able to write to this instruction. 1734. Or write to this memory address. Load word S020. You know what? Let's go turn on the advanced debugging again. Why not? Where is this thing actually exploding? Okay, we get down here, 1718. Okay, so bam. We skip to here. 24. What are we doing here? What are we even doing? What is this code? Why is there a constant here? Whatever. 20. 24 is... Wait, what is going on? Oh, I see. Okay, so 24 physically executes here. Okay. Then the next instruction is here, and that's when everything explodes. We don't print out stack pointer. Great. I guess we have to print out stack pointer. What even is the stack pointer? 29. Nope, that's totally a valid stack pointer. Okay, so what is going on?
Is this another null pointer dereference trap?
I'm not sure yet. I'm trying to
Okay.
figure out exactly which instruction it's actually exploding on. So this is saying that it's going to fetch 30. This is going to say that it is executing 2C. So it would be actually running line 28. So it would be running this instruction right here. Load word S1 24 SP. So it means, I think that means that instruction successfully executed, because S1 is being updated. So that means that it's here. So S0, store word 0 into 0S0. That should be totally valid. because it's saying store the number 0 into this memory address, and this memory address is kind of on the heap. I mean, I think it is. Let's double check. Oh yeah, it's right at the very beginning of the heap. 246A. So it's, yeah. Yep. Inside funbox memory. Why would that be crashing? Let's add some more printfs. Huh? Oh, here we go. Load 0 into this address. That looks like that should be fine.
That looks sensible.
Do we, like, branch right here? Is that what could be going on? No, we don't even... No, we don't... There's no branch... What is going on? Why is this crashing?
Hold on, what is the address? A. Yeah, that's failing your if address at 3 check.
Ooh.
That's an invalid address. It's unaligned.
Yes. This is a legitimate bug then. I should have known that immediately. Oh my gosh, I'm so goofy. We don't need any of this extra debugging. This is just obviously incorrect.
I mean, it's useful we saw the store and why, but yeah, it's just an unaligned store.
Yeah, so why is target unaligned? I guess dictionary would have to be...
Are character pointers on MIPS aligned by default?
I don't know.
Like, what they're pointing to.
But things will explode if they aren't, so... Oh!
Yeah, that's my concern.
Okay, so our target is wrong. And what that means is we're writing into the target. Env. That can't be right. Env... args... That can't be right. Funbox... Oh, that can't be right. We can't... Hold on.
You pass in proc env, not proc address of env. Is that why?
No, proc-env is an actual pointer.
Void pointer. It's the void pointer there. Void pointer has size of 1 in GCC.
No, that's not it. I'm dying. Okay. Okay, so what's actually happening is we decided to say arg list length bytes here. And that is the length of the command line stuff. But that could be like 2 or 6, which it is 6. And because it is 6, now And we need to round this up is what I'm saying.
I wrote basically the same code from my x86 kernel like a month ago, and I had that wound up in there, and I was wondering if I should point that out at some point, but...
Sorry, say it again?
I wrote very similar code for my kernel about a month ago to basically build the argument stuff on the stack of the new task. And I actually checked that code, and it does have that roundup for alignment.
Yeah. Yep, that's it. Okay, well we're gonna fix that. I think that's right. Oh. Oh. Oh, yeah. Okay. Well, that was nice. We only wrote like 3 bugs in that entire refactor. Oh. That feels really good. Let's clean this up, see how big it is when we're all said and done. Oh, we still have a lot more bytes we're using now. 212. It's like 100 bytes bigger. Oh, we still have the extra printf in there.
We're booting.
Booting, and it's no bytes bigger. Okay, there was some other refactor thing somebody mentioned. I think it was gosh, somebody mentioned something a little bit ago that we should have done, and I was too nervous to make the change at that moment. Dang, somebody had a really good idea in chat, and I can't remember what it was. But I didn't want to do it because we were in the middle of the refactor. I don't remember. Hi, Stay. Well, I guess now that we solved the problem, what was the thing? There was a... free-h? No. Oh, yeah, because heap does that. Okay.
You're absolutely right, Kayla. I'm not a large language model.
I too am not a large language model.
Yeah. I feel like most of the world would not understand the weird relationship that programmers have with AI and how there's still like so much like, I don't know. I know people who like use AI and everything and they're like, why would you not? And it's like within programming, it's like weird that the programmers are both the first and the last to like embrace it.
I'm not giving you a recipe for carrot cake, I'm sorry.
Bin sh. Where is the other malloc coming from? There are 2 mallocs that are happening. One malloc is 108 bytes. The other is 68 bytes.
That's... Oh, no, that's process space plus empty dictionary. Is that not?
Yeah, but it
64
shouldn't-
bytes for the process plus 4 for argc.
But it shouldn't be allocking. Hold on. It shouldn't be allocking another. Do we even call this anywhere? I don't even know if we call this function. No, we don't even call the create function, the dictionary function. Oh, we allocate the app data segments separately. That's fair. Well, should we? Should we put it all together? I don't know. I think it is time for a 3-minute break, and then I will go and I will explain 3-minute break, then I explain what all of this mess is. Okay. See you guys in 3 minutes.
See you soon.
Yep.
I definitely need some caffeine.
Oh yeah, I definitely need some sleep. I was about to head to bed when I saw the link to the live stream. So it's been
Then if you're
yeah.
heading off, have a good rest of your night. It's been nice talking to you though.
Yeah, it's been very interesting to watch this. And I'm gonna look at the recording for the actual details that are coming up. But yeah, good night.
Night.
Taylor, are you still around?
I'm still here.
So, I realize we can't keep the env with the struct, because if somebody does set env, we have to resize that array. We can't resize it if it's part of the, well, yeah. It's impractical to resize it.
Well, instead of having environment variables be a guarantee as part of the kernel, why not have them be part of the shell instead?
That's an interesting thought.
Yeah. So instead of having environment variables passed around and handled by the kernel, the shell owns the concept of an environment variable. And then anytime that an environment variable gets updated, it's owned by the shell's address space, and every other process has is just a pointer to it.
If you have a shell, well, no, because if you do set env in a child process, I don't want it to edit the parent process's env, right?
Okay.
Yeah. So it can still be a pointer. That's fine. We just have to care about it differently. So it'll be well, things like current working directory is something I would like to have as an environment variable, right? I'm going to have it a very American thing here. I'm making a pretzel with easy cheese.
This might be because I'm kind of hungry, but that looks really gross and also really good.
It's not really good, but it is tolerable, so.
I mean, I like American style, like really bready pretzels.
So we're going to do funbox. I'm just fixing this before I explain what all of this is, and then we'll go into the explanation.
Thinking about it, why would you want current working directory to be held in an environment variable? Is that just to take pressure off of the kernel needing to handle it?
Yeah, I don't think the kernel should care.
Okay.
Also, I love how we're calling it a kernel now.
Look, I'm calling it a kernel because it manages time resources and it manages memory resources. That's a kernel.
Okay, I think this is... technically correct now. Let's see. No, what did I do wrong? Oh. Uh-oh. Well, something is broken. LS is broken.
Oh, there's no files.
I mean, there's obviously files because I can like do things, but somehow it is broken. Okay, let's.
Oh, interesting. Apparently on Linux itself handles the current working directory.
Oh.
Yeah. I had a feeling that was the case, which is why I asked, why do you not want the kernel managing it?
Well,
but I didn't realize that the kernel did in fact manage it on Linux.
I don't want to manage it. I want
Yep,
the process. I want
that's completely
processes
fair.
to be as small as possible. I mean, maybe I'll change my mind in another like month, but we'll see for right now. Why is files broken? Oh. Uh-oh. Uh-oh. If I say LS... so the refactor did break something. I know what this is. It's all this junk here. And I say... Yes. Okay, that fixes it. Okay. We don't have dictionaries yet really functional because we can't like add and get env and stuff like that, but that's okay. We don't have to worry about that right now. We did the big refactor. Yeah, we still have to write that. Other than that, let's go talk about what this is. So I guess I'll recap everything that we started at the beginning. I would imagine that it's like the Oregon Trail where when you get somewhere, you've like entirely different group of people than who you started with. Yeah, it looks like we're about 36, 38 people. Let's go take a moment and just recap what we're doing here. What I'm trying to do is build something that is like a small kernel or environment for embedded systems. So this will be like a little shell, little environment that you can like type into and do things with on embedded systems. This started because I wanted to write an emulator on Shader Toy to emulate a system that would be interactive. And it was too painful to do that in RISC-V, so I decided to go to MIPS. Then I'm in MIPS, and I tried using little kernel, but that the point is like you keep going and going and going. You get something that's kind of heavyweight. And what my goal is to make something that's an environment where you can have like a cute little shell, where you can be like, do whatever you want to do and have like the sort of multi-user session. Not multi-user. You could do multiple users. This actually could be a multi-user session because you could have multiple shells running concurrently. And be able to you can stay here and yeah, I wanted to be able to sort of have this environment and be a base that other things could build off of. So sort of instead of spending all of my tokens doing really complicated things and like the sort of like RTOS scheduling and stuff like that, I decided to put it all into not having tasks. Well, having tasks, but having those tasks not have things like stack, so that all of your processes can just kind of be a function instead, and sort of like really aggressively keep everything simple. And just I was curious where this would end up, and this has ended up somewhere that's kind of neat, where for 11 kilobytes I have a pretty serious system. I don't want to say it's a serious operating system yet, but it does feel like this is sort of the direction that something could go. Like I haven't found any blockers yet for sort of keeping everything this simple. Instead of being able to have multitasking where things can be preempted and just like paused, instead it'll be collaborative where all the tasks will say like, hey, I'm done for right now, I can go let other things run, or that sort of thing. And that's what this general design is, or what the goals are. The general design, I don't know, maybe I could do this in GIMP here. Let's see if that makes sense. Boom. Oh. So in general, 32. No, it's too big. In general, what we're going to have is we're going to have a static image where what happens is the first part of this is going to be the code. And then what you have is you have a heap. And the heap is going to be a specific size. And then you have the stack. Actually, that makes me wonder. Oh yeah, I guess the idea is you define how big the heap is, and then the stack just uses up to whatever that is. Yeah. And inside the heap, we're going to have just various processes that live. And actually, I don't know why I'm going to this. I think looking at the heap view from inside the system is probably the best way to think about it and see it. Where you can see that sort of there's memory addresses right here, and those are mapped to applications. And as I showed earlier, if I say getty hello, or let's do you, because that's 55, that will launch me into a new getty terminal here. And I can say heap, and I can look, let's see, which one is this? I think it's going to live in 24E8 now. So if I say xd dev memory, and I go to 24 E8, 24, yeah, right here. So here you can see that it's inside the shell memory, the memory for the shell still of the parent, because it just hasn't been cleared. And then here's the environment or the command line parameters for the slave application.
It's in that twice because of the dictionary copy as well.
It's not the dictionary copy. This is the parent. No, because inside the parent, it's not. It's reusing the data. So this is still inside the shell's command. Yes. So this is
that's the command processor.
This is your slave process's argv, and then this is living right here. Okay. And the idea is that you could write little applications that would be able to be run alongside this, and also write like device files. So for instance, one of the things I did earlier, or what I did is I could say cat dev memory, and here all I do is I just give a pointer to the beginning of memory and the size of the memory, and then it maps that into the virtual, or into the user space of the operating system. So yeah, that's the this is the little thing I'm working on. One of the things that's unusual about it is all of this is targeting MIPS, and what this is using is my MIPS emulator, bittymips, and that's this little file right here, where this is all you really need in order to emulate MIPS. It's very short. A lot of this actually can go away. A lot of the instructions I added are for specifically trying to support little kernel, and that will only build on certain other processors. So I probably could get rid of a lot of these. I mean, heck, let's take these out and let's see if it still works. Top doesn't exist. Oh, yeah. Okay. Yeah. Yeah, I know. I typed it in like a goober. So MIPS, I can explain that one too. So I'm the author for Mini RV32 IMA. And what this is a single file header library that emulates a RISC-V processor. And this is about 500 lines long, and it's written in such a way that it can compile for HLSL or any C-like language. And because I did that, people have ported this to all sorts of bizarre things. And what I'm trying to work on now is something that's simpler. And one of the annoying parts about RISC-V is that it has some very arcane, just a lot of messy stuff you have to do to get a lot of things working. And MIPS is a little bit simpler. And so what I'm trying to do here with the MIPS emulator is keep it very simple. Actually, I should put this in the attic because I don't need it anymore. And trying to make just a very simple system that should be able to run all of this. Do I need? I don't even think I need those two instructions.
Yeah, when you first showed this off on the weekly call, I was surprised at how tiny it was. No.
Yeah, I don't even need these other instructions. So this really does get ridiculously small. So yeah, this is, I think, you don't need move n either. Well, that's actually useful instruction to have maybe someday. Anyway, my point is, yeah, it becomes a very simple to implement thing, and this is something that is likely to be able to be compiled and run for ShaderToy. Yeah. Liuma, CD is actually not an application.
They meant in terms of funbox.
Okay. So yeah, that's where I am right now with all of this. Very, very simple CPU. But the really convenient thing is it has GCC support. And so that's where we are. Yeah. I guess we should finish up dictionary support and then add DD, right? I think that makes sense. Should we do... we could do it in that order. And then we could... yeah, I'm trying to think. What would we want to do here? Okay, you really want DD. I think DD is a good move. So we could write the first half of the dictionary stuff, which is get dictionary value. And then we could write DD, and then I could write the second half, so we can have get env and set env. And I think that would make for a pretty good live stream. Does that sound good for everyone? If you have other ideas, I'm happy to take them, but I think that's the direction we'll go.
DD works because you had to change a lot internally to do it. And then it's a new application.
Yes, I think that gives us a nice, like, stake in the sand to say that we actually did something. Hold on, I just want to look at... I have to say I'm still... Oh, no, that's right, because it's... Hold on. Real quick, I really want to flip one thing around. I want to make it... Okay, actually, Kayla, let me get your opinion on this. Or maybe we could do that at a later time. A big part of me wants to make the process data segment part of the process. And another part of me wants to make it so that the OS couldn't care less about the data segment and let that be on the process itself to decide.
That is a good question. It's about if the kernel needs to manage these things, is the really important question. Does the kernel need to be managing memory? If the expectation is that you're going to start a lot of processes that do a lot of different things, like you would on a modern system perhaps, I think the answer is OS needs to manage that kind of thing. But if the answer is OS doesn't care...
The OS still manages memory, but the question is, does the OS expect that there is the idea of a data segment?
I think it's a useful thing to keep track of.
Okay. Maybe at a later time I'll remove it. The one thing I'm thinking of is it means that then an application could strictly be a function pointer. As in you don't need to keep a You don't need to keep the idea of how big this application stack is along with it. But at the same point, it means that now every single application that needs state needs to be a little bit bigger to go make the function call to say, hey, give me some memory.
Well, I mean, if you want to make the kernel slimmer, I think then OS doesn't care, but the applications still request memory from the kernel.
That's what I'm thinking.
Yeah.
I really want to write this. Okay, let me... I really want to do this first. I know that you guys want to have the other thing, but I want to try this.
This also makes some programs use less memory, like Echo, because Echo doesn't need to allocate any memory. It just reads in argv and pushes it back out again.
Yes. I just love the idea of there not being applications anymore. Oh, it's so much tidier, I think. And it also means that you don't have to go look up the application to get the signal. It'll be a direct jump into the applications. It would be like it's one extra layer of indirection every single time you call anything to do with a process. Could we have... Is it possible to have an application without a signal? I think no. I'm going to just say no.
No, because there's no... Because if you've got a process, you expect that it has an entry point.
Yeah, and there is no app. Instead of it being app image, it's going to just be signal. How many operating systems do you know go through points where they simplify the abstractions as things go on?
I mean, I think Linux definitely tried to simplify its internal abstractions, but that's mostly stopped by the fact that it gets more complicated every year, just because it gets more features.
That's fair.
Like when they brought in the usage of generic to create type of on-call, that was to simplify some of their interfaces where they had a million different duplicate functions.
Funbox signal helper. Okay. Let's see, what's the next error? Funbox 173. There is no more app. There is no more app. Yeah, there's literally no more app. Okay. Next one is 326. Funbox CB opaque. Size of funbox signal. Where is this? Dir from array. Oh, when we get a directory callback. What is that parameter? That's weird. What am I doing here? Port callback. NPA. Util dir from array. Oh, that's right. Do I care about this? Wait, funbox opaque prefix directory. What was that again? I don't have a memory right now. Size. File size. Oh. I don't know why I did that. I'm just going to say 0 and see what happens. Because directories don't need to have size. That's just silly. 618. Signal helper. P. Signal. P. Wait, what? Called object is not a function or a function pointer. Process. Process signal. Oh, it's not a pointer. It is a function pointer. It's not a pointer to function pointer, which is what it was before. So we're probably gonna have some errors. Or not, it's just gonna work. Funbox apps line 24. We no longer... Wait, no, we still have app data. What did I do? What? Did I really get rid of that already? Do I not remember what just happened 5 minutes ago? I guess I did. I don't remember getting rid of that. I thought we talked about that, right, Kayla? Oh!
Pardon, sorry?
Part of getting rid of apps is getting rid of app data.
Yes,
Okay.
because they're managed by applications, so they need to allocate
You
themselves.
know, it's funny that I could forget that so quickly. Well, I still need to have a pointer to my app data. Shoot.
You do, but this is now something where, oh.
Like, there's literally nothing in this process struct now that makes it so things can know.
Don't get rid of... Because you just want to be able to pass a process in, right? To the application?
Yeah, but I do need... I'm just saying that, like, a process needs to be able to somehow track some sort of state of some kind.
Yeah, I think having a void pointer about data is fine, and it's unmanaged.
Totally opaque, it gets initialized to 0. Okay, now funbox apps. Oh, we are going to have to allocate them, though. Huh? What does that mean?
I don't think you need the cast there anymore. No, you do. You do.
Is that the right syntax? It is. Okay. And shell is the other one, right? I'm going to reformat this just so it's clear. Okay. Oh, what? What? Come on. Oh, it's not cat data. Now it's shell data in this one. Okay. Good thing that that's an error instead of oopsies doopsies. Okay, so now we no longer have any of this extra stuff. Oh. Oh. 0, 0. Test.c, line 71.
Yay, more microwave ASMR.
Oh, funbox signal. Okay, and then this one is size of test line 80. Size of funbox signal. Oh my gosh, we saved almost 100, not 100, like 70 bytes. And it's dying. Okay, well let's figure out why. 022A0.
Does shell allocate for itself?
I did write that, but maybe I didn't write it right. No, it's right here. This is all correct. Uh-oh. Oh, I'm taking a pointer to a signal instead of the signal itself somewhere. I'll bet you it's on init. I'll bet you that's where I messed it up. In here. Okay. Image length is not used anymore. Well, we'll just have to trust that things can run. Okay, that didn't work. Ooh, what is going on? Oh no. Is this wrong? Pointer to a signal. Is that a pointer to a pointer? I'm so confused right now. What is image file? Oh, I think I can make this work right now, but I'm trying to think of how the right way to do it would be. No. This kind of makes sense. So maybe there's a way to make this cleaner, but what happens is this right here is a thing where it has a pointer. No, I need to figure out what's going on here. This has a pointer and another pointer. Funbox apps. We pass this into util file open from array as the last parameter.
Apologies, I should have been paying more attention.
So what had happened was, before I was expecting a struct, and the size of the apps were like 8 because it was the size of the thing plus the pointer. But by just making it a raw pointer to a function, things get really hairy. Because inside these structs, the payload is not... Yeah, it... I'll be darned. Just notice we have a... Okay, time to go clean some of this up. Funbox.c, line 160. $11044. Okay.
We got it working?
Yeah. And it is actually less space still. I guess that'll go away when you have more applications that need state.
I have noticed something since the dictionary changes.
Okay.
Echo is behaving wrong.
What do you mean?
Echo is printing argv0.
Uh-oh. You're right.
I noticed it a while ago, but I didn't know. I couldn't remember if that was like what happened before. But now seeing it doing echo hello world, it's acting funny.
Uh-oh. How would we do that? Funbox print dictionary. I guess it would have to take in another parameter? Good catch.
Alternatively, change the first argument in the list in echo to a nothing string. Just put a /0 in it.
No, because then it's going to still have another space at the beginning.
True,
Oh.
true.
Oh. Oh, yeah, no. Wait. We could be really evil. Oh. Oh yeah, you can't modify it that way. Okay. Why not? Hold on. Well, this is going to be extremely evil. Do you like my code, Kayla?
You know, it fills me with a kind of dread. You know when you wake up at night, like just as like right as you're about to go to sleep because you like jolt awake because you felt like you were falling. That's what this feels like.
As well it should. It works. It works.
It does work, and it has fixed that bug in Echo.
Static assert. Size of that must be equal to size of that.
Oh, this is atrocious.
I mean, it has a static assert. I hope more people write tools like that. Okay. 11060. So now is when we add getEnv. But not getEnv, just dictionary get. So we can get DD. Yeah, so now we're going to do DD. Sorry that took so much longer, but we ended up in a much nicer place for it, so.
Just don't look at Echo.
It can't hurt you.
I mean, I'm glad I caught the bug because it seemed like you didn't see it, and it's going to be one of those things where you
No, I
see it
did
in like
not.
3 days and assume that you broke something else.
Yeah, I'm really glad. This really is a lot easier with multiple people. So now we do the weird stuff. Get dictionary var, and then the way I usually do this kind of thing is I go to where the dictionary definition is, and paste it in, and I say if not D or, oh no, if not D, let's just assume dictionary is always present. I don't want to bother with a zero check here. Int I, for I equals 0, I is less than D arg C, I plus plus, if stern comp var arg vi, I don't know, just, oh shoot, that's gonna be ugly. No, I just have to process it myself. D arg vi. Char C. while do, I'm going to structure this do, I think, c equals star n plus plus. If c, I need c and d. B is, or sorry, B star var, oh, I can't do that. Int p. And p var p if c equals v, continue. Oh, c is not equal to v, break. P plus plus. While c equals v. And c? Yeah. Well, no, could you ever have...
Why not use string compare for this?
Because I need to look for the equal sign. You're looking for when, like, I need to get the number of characters in. So now here it's going to be if c is equal to equals, then we know we have a WinRAR. And it's even more convenient because p is now pointing to the character after the equal sign, and we can just return n plus p. Yeah. Otherwise... Yeah, it gets this. I mean, this looks very strange, but I think this does everything. And this
I see. So in a dictionary, key value pairs are stored as a single string.
Yes, yes, they are. Yes.
Okay, this clears up a confusion I've had for the last like 2 hours, I think.
Okay. There is one thing that's a little annoying. No, if you're going to say get dictionary, you're going to assume that it's like there's going to be an equal sign operation going on. Yeah. So like if say we're using like DD and we say -p, just throw it out. Like who cares? It's not going to We could have another thing which is like does have flag, and you pass it a character and it'll tell you whether there's the flag in the dictionary or something, but or it could tell you
Okay, interesting. So you could, instead of having it be key value delimiter is equals, you could pass in the delimiter you care about.
Why would you do that? Like what use case would that be?
Because I thought that's what you were just saying.
No. What I'm saying is there could be a different function which is has flag or get flag, and it will return to you a pointer to the flag or an index. It'll return to you an index to the flag, or like -1 if there's no flag.
Okay, that makes sense.
And that would be for like if you want to say like, did I say free-m? Which honestly, maybe we should have some Easter egg for free-m where it just prints 0 or something. Or credit.
You put in free. It's like the AFL++ April Fool's joke.
What's that one?
Oh, this is a really funny one because they had to add an environment variable to disable it after companies complained. They added a pizza mode. So on April 1st, instead of the fuzzer showing you stats as like a fuzzer would, it shows you stats in terms of like a pizza restaurant.
Oh, well, that seems... I'm not familiar with that one, but okay.
It's very silly, but they had to add an environment variable to enable it because companies started complaining that on April 1st they got pizza moded.
All right. Now here's another crazy question. Can DD just be cat? I think DD can just be cat. Oh, this is going to be a really cursed command. No, I don't think DD should be cat. Oh, hold on, I forgot. Let me make sure LS still... Okay, LS still works. Also cute. Now these commands are only 4 bytes each because it's just the size of the function pointer. Wouldn't it be cool if we could get size of function in C, Kayla?
You know, that would be really cool. I wonder if someone is in the process of writing a request to the C Standards Committee about that. I wonder.
That would be interesting. Nobody would ever do that.
Nobody would ever request that the C Standards Committee change anything. That's crazy. What are you talking about?
Okay, what do we need for DD? It's like, what are the options for DD? Oh my gosh, I didn't know you could use DD to... What? What?
Yeah, DD can do a lot.
Well, we're not going to implement all of that. We'll need a new flag for seeking. Do we want to seek, or do we want to just ram jam the pointer? I think we just want to ram jam the pointer.
Nothing bad ever happens when you ram jam the pointer.
Nope, it's always perfect.
Yeah.
Oh no, I just realized I don't want to do this. Actually, I do. To do, check to see if we should yield. Okay, and we'll do the same thing in DD. There is no next file. Let's just no. Terminate. We terminate here. Ooh. Do we do this? Yes. We're not going to support hex mode because we could just pipe it into XXD.
As a heads up, you're still doing size of cat data when you create your data struct.
Done. Fixed. We probably don't want to go through printf to output things by DD. How does this work internally? Oh, it literally calls file.io. Let's do that. Okay.
You might want to add a cap to BS.
Nope. The user crashes,
No?
they crash.
The user overwrites RAM with a 2 kilobyte sized BS buffer.
I don't see why not. Okay.
We getting Windows 95 in here.
Yeah, that's, well, it's more like Amiga, I guess. I don't know.
Amiga Workstation mentioned in the Big 2.6.
Oh boy. Okay, so if we start, here we are. Now we have to go. We have to go do the stuff. In file, or in name is equal to, and then we're going to call that newly made dictionary function. I don't know. Key, no value. What is the... Yeah, let's do funbox get dictionary value. Otherwise, it's really confusing what that really means. Okay. Process command line. What is it? IF? Yeah, IF. If in name. Oh, I don't even have to check there. I could just try opening it. What is the return value file open function? Bool. Oh, this is glorious. Look at that. So simple. This is kind of ugly. I should really have a helper for file open, I think. We'll do that later. I mean, let me add that to the README. Oh, if not... Do we want to tell the user what they did wrong?
Yeah, but do you want to do that through a print or through a return type?
I want to do it this way. Oh, this is going to get so cursed. I love it. Oh my gosh, look at this monstrosity. No, I'll leave it how it was. Okay, OF bad. Oh, heck yeah, let's do this. Make it really short strings. Okay. IF, OF, okay, BS. So that's DBS is equal to A to I that. If not, that is equal to 1. Okay. Count. And if you don't have a count, I'll just not do anything. That's fine. The seek equals, and if we seek and it doesn't exist, then we'll just not do anything. That's a question. What happens to A to I if you put in null?
A toy null, I think, is safe. To see Sanit function.
Where did I put my A to I? I guess we'll find out.
Oh god, I'm gonna have to go look at the C standard to find this out.
Seek, skip. Ooh, should I have a new thing which is funbox get dictionary value int?
You could. No, I won't recommend that. I can't, in all good conscience, recommend what I was about to say.
Okay, well, I think this is it. I think if we don't have an error, then we probably continue on. So we do have an error, then I will print some error. We don't have a next file. I guess we just jump straight into try read. We do have to close the files.
Apparently, a toy null is safe to do.
Well, I guess we'll find out if it is safe to do in my function. Hmm? Oh. Oh, that's interesting. I forgot about that. What? Well, it compiled, and it is, I don't know, that's an extra, like, 800 bytes? That's really big.
But just the passing of DD?
No, that's all of DD.
Oh, that is all of DD. Okay.
Yeah, we have DD
I mean,
now.
that's not terrible.
Yeah, exit help cat DD echo DD IF is slash. Oh, actually, let's do heap. Getty you heap. Okay. That would be DD IF equals dev memory. BS equals 1. Count equals 1. No, count equals 100. OF equals dash. Oh, that's disenchanting. Yeah, ADI is used in one other place. Don't remember where.
But I mean, a toy is a very simple function anyway. What are you expecting to happen when you write dash?
Standard out.
Oh, okay. Sorry, I didn't quite understand because in the heap view you've got dashes being free memory. Why would floating point passing be? Oh, I guess floating point would be kind of annoying.
Yeah, I'm not doing that. There is no floating point here. It does not exist. It can't hurt you.
Yeah, it's mainly because a toy pulls in, it uses string to long internally.
No, I use it somewhere. Where do I use it? I think it's in this file, actually. Right here. Sleep. Sleep needs to know it. So no, it's clearly opening something. Let's try to debug in the kernel where dev memory gets emitted. Oh, it's not actually... Oh, ew. Where is that? That's some magic place. Here, file memory read only. Okay. Oh, that's going to be a painful to find. Well, it never got here. Okay, wait, hold on. XXD dev memory. No, that did work. What is going on?
Can I see where you actually do the read in DD?
So I have to keep retyping it. Let's just copy paste that. Hold on. I'm sorry. Give me a minute here. Opening DD, size of 4. Okay, fine. Oh, interesting. You know what we should have checked? Oh no, it found dev memory. Okay. What is going on here? Who knows why it pulls off the / whatever. What is going on? One C, 8C. Let's make sure that's the right place in RAM.
I don't know if that's correct. Look at where it's opening from in all the other ones. It's just 018C.
Right, but that I think is no. What?
Sorry, ignore me. I was thinking of something else.
I have to be doing something wrong at the call site. Like, there's no other way. Oh, well, no, it's in file. Yeah, that's right. Oh. I was overriding it with the standard terminal. Ah. Wonderful. Oh, wonderful. Oh, wonderful, wonderful, wonderful. Okay. Well, that's not quite right. I just dumped all of RAM. Oh. Oh. Glorious. Okay, so Getty. Oh. Getty. You. Okay, and then now we're going to say heap. And then now we're going to do dd if equals dev memory calc. We're going to try to get it from this Getty. So hexadecimal. Oop. And that's going to be 10752. Is it skip or seek? It's skip. Oh, we don't actually implement skip yet. Man, DB. What is it again? Seek is output. Oh, I don't want to change the opaque. Hold on. Let's see. Pos. And we are still not quite adding seeking. Okay, that's good. DD, oh, not DD. Oh boy, that exploded hard. DD exclamation point OF. Go to terminate. Oh boy. We need to protect this somehow. Getty U, okay, and then ED IFE def memory OF equals, oh shoot, no, I need heap. Okay, and that's going to be 2818 in hexadecimal, 10.6.264, and 2DD, man deep. Skip. Okay. Getty, you, hello. Okay. Deep. 281C. 210.268. Okay. DDIF equals dev memory equals dash BS equals 1. Count equals. Oh, I don't know. 100. And I just had that. And D. Skip equals 10.268. Did not work.
Is getting it from 281C correct? Wouldn't it be getting it from 27C4?
It's not skipping it. And it probably will be 2C7, 2C2. Yeah, it'll probably be. Oh, you're right. But it doesn't matter anyway because I just tested with skip not being set and it didn't do the right thing. So.
Yeah.
Did I got it wrong in my code again. Seek. Wait, in file. Okay, so seek is out file. Skip is in file.
Then using seek, you should be able to get the behavior you want, right? In the terminal?
Give me a second. Oh, great. Now we don't know which one it is. Well, we could try one and then the other. I don't think it's that one. 10264. No. Wait, those look suspiciously similar. Oh, this is the top Getty. Okay, so no, where is the string held? Hold on.
Q7 BC.
Uh-oh. What? Oh, is this because the parent owns the RAM of the child block? I think it is. So it would be in 2.7 VC. Is that what you said?
Yeah.
Okay. 10.172. Okay, we'll try that. Oh, we have DD. Okay.
A.
Oh, that was a good stream. Well, now exit's not working. I gotta figure that one out. Why is
Exit
that now?
too big?
That's a very
Maybe try
strange
it.
error.
Yeah. Maybe try exit from a fresh boot.
How is that possible?
What is the too big error? Like it tried to allocate something that was too big? Oh.
Yeah, but this could also happen if there's a signal that's unhandled.
Yeah, you don't handle funbox terminating.
No, that's not a signal, that's a state.
State, apologies. Maybe try printing the... Yeah.
Okay, so too big is a hold on, what is the event? How could that get there? I'm not gonna have that. We're gonna put the error here. I'm gonna rename that overflow. 4? What is 4? Oh. Exiting. Okay, that's fine. Yeah, okay. Like, if you're gonna fail, you're gonna fail. Fine. Or exit, you're gonna exit. Okay. Oh, okay. No, this is doing the right thing. Heap? Exit? Heap? Yeah, it's doing exactly the right thing. Okay. Yeah. 11,956.
I mean, for adding, did you commit after adding the rest of the dictionary stuff?
No. This
Okay.
is the rest of the dictionary stuff and DD. Although I kind of want to look at the size of the DD function now. Just by looking at it in this, we'll probably learn something. Wow, that's oh, it's the last function in RAM. Okay. That's a chonky function. 672 bytes.
Ooh.
What can we do to fix this? I don't know. This is ugly.
Oh, that is a lot of what looks like spilling.
Oh yeah, it's spilling like a banshee.
What optimization are you set to? O2 or OZ?
OS.
Oh, not as strict. Okay.
No, OS. S. Small.
Unless I am wrong, OZ is the stronger version of OS.
Well, let's find out. It is exactly the same size.
Okay, never mind. Imagine any savings we could have gotten from OS have been eaten up by alignment restrictions and other sorts of things like that.
So maybe it's time to refactor some of those functions I mentioned. So inside the apps, a lot of places where I'm doing file IO, it's kind of Ouroboros-y. Where I'm saying like dd in file IO blah 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 blah, and I really could just make it be like file IO, and you give it a pointer to the file, and you call funbox read. Like the stuff out front is not needed. We could have a helper.
Do you really think it's the number of function calls that are causing this, or?
Not sure. I really want to clean this up though, because this just to me looks so ugly.
It's more registers than you'd think, especially when you involve variadic arguments.
Yeah, but these aren't variadic. We aren't calling any variadic functions in this thing. Oh, we are.
Yeah,
But-
yeah. I was
but-
just responding to Sam.
But this compiler isn't doing the nutty stuff that the other one was doing. Oh. Oh, hey, we're back. Wait, what was the size? 956? Oh, come on. It's no savings in space. Well, it's prettier. Okay, really, we got to figure out why this function is so bloated. What is going on?
Can I have a look at the assembly output?
Yeah, let me put it in the paste bin.
Yeah, I want to stare at this to see why it's so crazy in size.
Sam, the calling convention for MIPS, you should probably just look it up, the registers, just so it's clear, but the idea is that S0 through S whatever is not affected from calls, but A0, A1, A2, A3 can all be crunched, and they can't be trusted, and all the temporary registers can't be trusted.
A lot of this stuff looks like it's been very, very heavily optimized, but then you've just got these two enormous blocks of store and load word.
Yeah, but there's like a lot of stuff. Like, maybe if we like rearrange the arguments somehow, I don't know. It feels nutty.
Yeah, because it spills 0 to 5, the return address, which is obvious, then S1 and S8. And then it loads all of them again.
Yeah, but that's so the idea is that the front and back of the function are at the beginning of the function, and the rest of the function is the innards of the function. There's got to be a better way of writing this. There's no way. I refuse to believe that it's like literally 600 bytes of extra stuff. That seems so ridiculous.
128 bytes in this function are just used up for these stores and loads on the stack.
Yeah, but that's probably real. Like, I mean, you have to store and load literally every single variable you use inside this function. That you don't want clobbered by an inner function.
I mean, this all seems very reasonable. DD has a lot of functionality in it.
Okay, I have a new idea. Kayla, you're the one that knows how to do magic stuff here. I want to make it so that I can configure which of these things get included or not. Oh, wait, duh. I can just include them or not down here. Okay, well, what I want to know is, is it possible, so I don't need this list, so I could, for instance, say inside of each one of these, like pound define, concati, and then I'll say, like, sleep signal, or add to list, and then down here I'll like, here is my list. Is that possible? Like, make it so that the macro would at each one of these functions, it would add one of these entries, and then down here it would populate the rest of the table. Is that a possible thing to do?
Let me think, because I think so. Yes, this is... Oh, hold on. I'm trying to think about the best way to implement this that isn't horrific jank. The answer is yes, I just need to think about it more. These kind of... it's a weird one to do this. Because what you would need to do is you would need to have some kind of number that gets appended to here. So you've got like a... Yeah, how terrible is this actually? Let me cook something in Godbolt real quick, and let me see if I can figure something out.
Okay. There's also one other thought I had, which this is kind of like a usability question, and I think I'm about to enter another brief break. But I was just thinking, wouldn't it be neat if the size of the functions actually were visible in the thing? Like, inside the VM, you could be like ls and see how big cat really was.
Yeah, that would be neat.
So that would mean that we would have to have like a beginning and an end, and I think you would do that somehow. Oh, you'd have to put every function in a different section. Maybe that's not for the stream though. That would be something I could do on the side.
Yeah,
but I would love to add this on the stream, so we could have like a list of the functions that you want to have, and yeah, like I would love to do that.
Yeah, I mean, with post-processing, that would definitely be doable.
Oh, but I don't want to post-process.
Yeah, you build it and then you insert something into the binary to like after it.
Oh no, I'd like to do it in pure C if I can.
Ugh, yikes.
Well, no. If I was to do sizes, if I was to do the size thing, I would. Yeah, we'd have to post process that. I'm saying for this,
yeah.
the like, yeah.
Oh yeah. For getting function sizes, yeah, you'd have to post process. For the list, I'm just gonna have to cook in Godbolt until I find something that works that isn't terrible.
Okay, then I'll let you do that. I'm gonna go take another look at this. So DD is now checked off. Dictionary support is almost done. We have to add dictionary writability. No, X macros involves pound including a header file. Do we want to get rid of PIDs? That would be an interesting thing to do. Just make it so you handle processes everywhere. Well, no, because we do want PIDs. Okay. Yeah, I'm going to take a minute off. I'll be back, and then I think we're going to decide what to poke at next. I think I want to do the thing that Kayla talked, and maybe we'll try to get maybe the rest of the dictionary support in. I don't know. I still have some energy. The tea did well, so yeah. Yeah, this is going well. Okay, back in a minute. Oh. Does anybody else have any ideas of any directions they'd want to go? It's kind of open floor now. I mean, what's this? No.
I am back now.
Yeah, I'm kind of open. I don't know. I'm a little sad that people didn't join from the rest of the server, but I guess it is what it is. So.
I think if you did it on a different day, you might have gotten more people on. RAMFS might be interesting.
Yeah. It would be easy to do. You could just make it so it's a certain size, and then if you need more, you just reallocate. And that would test realloc. We're not testing realloc yet. I think pipes and RAMFS go together. Is RAMFS is part of the core? Well, this is tricky. Hmm. Hmm. It's a little tricky. So what I'm trying to figure out is, do I want the file IO to be ultimately owned by the container, or do I want it to be owned by the kernel? Sorry, like the file open and file dir commands. Like, I could make a function. Well, Hmm.
Okay, after cooking a little bit with macros, I don't think this is going to be possible. I thought it was, and then I realized I was being silly because we don't have counter in C yet. Having counter in C makes this possible. If just barely makes this possible. But without counter, there's no way to create a unique ID that would be accessible again from a list macro. Your best bet would probably be doing some kind of X macro. Maybe. I'm not 100% sure.
I don't want to do X macros.
Yeah. There's something that in C2Y this would be implementable, maybe, but as it stands right now, I'm not confident in that.
Maybe the answer is around each one of these, it's like pound define, or pound if def, funbox has cat.
I mean, alternatively, split all of the applications out into their own files, and then have
No.
it be a configuration at build time.
I hate
And then you
lots of
pull in those files.
I hate lots of files.
Counter support's pretty widespread, but I don't want to add a C2Y dependency.
I mean, what is that? That's like GCC 12? And nobody's going to be building this in Visual Studio, so, Microsoft Visual
I mean, you can assume that MSVC is not a compiler, and so you don't have to worry about it. Yeah, that does also work doing it through a linker script rather than doing it in pure C. It's also how we do it at work for these kind of things with auto registry. I have the link. Probably, yeah, you've got it.
Yeah, we could give each thing a different section, and then that would make it possible to do the sizes as well. Actually, you know what? If we could use counter, we could put them in like incrementing sections, and then just have a billion things in the linker file, and then you wouldn't have to touch the linker file to change that list, and I would get my thing as well.
Does the linker script run the C preprocessor? Or can you define like an upward increasing list?
Well, you can do that with X macros. I would just have the linker. It doesn't matter if the linker looks like garbage. I could just have like instruction 1, instruction 2, instruction 3, instruction 4, instruction 5, instruction 6, blah blah blah. Yeah.
Okay, let me cook something.
Okay. Oh man, I had another random thought here. Okay, this is gonna sound crazy, but hear me out. Here. Oh, but then you couldn't have weird things. Eh. Now I don't remember what I was going to get started on. Oh, file IO. Yeah, I kind of got stuck on that. Because the whole thing is like, do I leave it outside or do I bring it inside? Oh, and the other question is like, do I have like pointers to file systems? Like, how would this work? I mean, maybe that is it, actually. So, the reason I say that is because, like, these two calls are almost the same. Yeah, I guess that's it. Yes, so I think I just want to add mount points. I think that's just it. Like, not mount points, but like mountable file systems. Yeah. Well, let me go do that first. So if we add mountable file systems, then we add the writable memory stuff, then we could do pipes. I don't think I'm going to get that done today. I'm going to put a hard close on this at 8 hours, but yeah. Yeah, I think we could do that. No, because file I/O for writable files is going to be weird. Like, the existing file I/Os work for what they work for. This is not nearly as much fun when it's me thinking about what to do, I think. I'm not sure. What do you guys... I want to find a way to make this kind of stuff fun. I don't know.
I mean, it's kind of difficult when you're just thinking on your own.
Yeah, like, I feel like maybe the answer is we might just be out of things that I can do for fun and quick now, and then...
It's the one thing I struggled with when I was streaming programming was, how do I make this fun and engaging for people who are watching?
Yeah.
Because the subset of people who enjoy watching programming and the subset of people who enjoy watching someone think they are two independent circles.
That's true. Yeah. Yeah, because it's like, I mean, I think if I just sleep on this, I'm going to have better ideas here. I guess I don't want to do that at this time. I feel like there's got to be some cleaner way to do the file system stuff. I think I'm just going to call it. Yeah. Well, thank you everybody for coming out. It has been a lot of fun. Yeah, this has been a lot of fun. Trying to think if there's anything else. Any other thoughts, anyone, before we end it? Okay. Thanks. See ya.
Thank you.